Ahí está. Ahora sí.
Aló, 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 aló.
still almost. I don't know. All right. Welcome. Good morning, everybody. We're here to hear a talk about adding a backend kube proxy next generation, a backend 2 kube proxy next generation by Rashes and Neha from VMware. Let's give them a warm welcome.
Thank you. Good morning. Welcome everyone to this session on adding a backend to kubeproxy next gen. So this is going to be focused around like concepts or basic concepts around kubeproxy, kubeproxy next gen, backends to kubeproxy next gen, and things like that. So before we get started, can I get like a quick show of hands of how many people have heard about KPNG or kubeproxy next gen? 1, 2, 3.
Is this the product that Jade asked for?
Yeah.
I'm gonna throw a shout out to him. I'm sorry about that.
All right, so like 4 people in the room and 4 or 5. And how many have like tried or used KPNG or, all right, like Ricardo? Cool. All right, so I hope that, all of you will be able to get something new out of this session. Okay, so let's get started. So who are we? I'm Rajas Kakurkar. I am a software engineer at VMware. And I'm also contributing to upstream Kubernetes, mostly in SIG network areas of late.
Yeah, I'm Neha Loya. I'm working in the Tanzu Service Mesh team. I'm also contributing to the upstream Kubernetes, mostly in the SIG network in this project.
Cool. So we're going to talk about KPNG or kubeproxy next gen. Go through like the current state of kubeproxy and then focus on backend aspects. All right. Okay, so what is kubeproxy next gen? So this is like a working group under special interest group network, it's SIG network in the Kubernetes ecosystem. So we're basically trying to redesign the architecture of kubeproxy over here. So we're aimed at like decoupling like the data plane from like the Kubernetes control plane, improving scalability, improving the ability to integrate third-party environments, being library-oriented to allow packaging logic at distributors well and things like that. All right. Okay, so the problem at hand over here is that if any client tries to reach out to a service, then they should be routed to one of the endpoints, right? Like one of the underlying parts that run the app. So the way cupping tries to solve this is through something like a cupping server. So this cupping server is, it has an API independent of the Kubernetes API. It's like a localhost gRPC server, which tries to watch Kubernetes API server for like services and endpoint resources. And then it processes this with Kubernetes business logic, like topology, computation, and things like that. And then provides like a local state to a cupping backend. So a cupping backend there can be like different backends. There can be like NF tables, IP tables, user space, and so on. And the backend is then responsible to take the state from the server and then implement the routing rules or the specific proxy, right? Like maybe user space mode or IP tables mode and so on. All right, so and then the client can go through those networking rules and then reach the underlying part of the service. Cool, so this is what cupping architecture looks like. I don't expect y'all to go through like all of these bits in one go, but like what I'm trying to highlight over here is that there's a split between like Kubernetes API and the cupping server API. There's a decoupling between like which part watches the Kubernetes API server and which part processes that and does the networking rules part of it, right? Like the point to highlight over here is like a backend is a pluggable entity. It comes with its own Go mod. It has its own dependencies. So a cupping backend can grow at its own space independent of the server. All right, and we're going to focus on the backend aspect a lot in this. Okay, so this is cool, but why do we even care? So for that, we'll have to understand the current state of kubeproxy, and Neha is going to walk us through that.
Yeah. So let's try to understand what is kubeproxy. So as we probably know, like kubeproxy is the Kubernetes proxy which runs on every node in the cluster. It manages the service abstraction within the Kubernetes. It runs as a daemon set within the Kubernetes, and yeah, it runs as a daemon set within the Kubernetes, and it manages the service abstraction within the Kubernetes. If you
I'll do that. Yeah, I can take care of this.
yeah, okay. Yeah. So let's take a look at this diagram. So whenever any new services is created, there is a change in the endpoint resources. If you see, like this information is then persisted in the API server and it is continuously synced with the kubeproxy. So what happens actually is whenever any new service is created in the Kubernetes, underneath there is a change in the endpoint resources which happens, and kubeproxy tries to program the network rules on each of the node in the Kubernetes cluster, and the traffic is then redirected to the appropriate backend pods. So if you see from this diagram, the traffic, suppose a service is created in the Kubernetes cluster, let's say a Nginx service, which is exposed as a cluster IP. So what actually happens is the traffic comes to the cluster IP, but if you see from this diagram, the traffic is actually redirecting to the kubeproxy, and then kubeproxy is redirecting to the backend pod. So this is a screenshot from the user space mode. So here what is actually happening is the traffic is going to kubeproxy and then it is going to the backend pod. So what will actually happen in the next? If you see from this picture in the IP tables and the IPVS mode, whenever a service is created, the traffic, instead of going to the kubeproxy, the traffic is coming to the cluster IP, and from the cluster IP, it is redirecting to the backend pods. So if you see, all the routing is happening in the kernel space. So this is the one advantage of using IP tables over the user space mode. This is the diagram which is from the IPVS mode. If you see here, the IPVS, the cluster IP is acting as a virtual server here. This IP does not change, as we all know, and the client has to just store this information if he wants to redirect the traffic to the backend pods. Otherwise, if services would have not exist in the Kubernetes, the traffic would have to actually go to the backend pods, and as the pods are ephemeral, it is very difficult to keep track of all these IPs. So this is, we have seen what is kubeproxy. Let's move over to some of the limitations of the kubeproxy. As we see, like kubeproxy does the networking part, and Kubernetes API server actually watches the bits in the single process. This is a blog post from OpenAPI which we have took, where you see like as and when the nodes increases in the cluster, the Kubernetes API server has a heavy load of watching all these endpoints. So if you see, as and when the nodes increases in the cluster, the Kubernetes API server has a very high load, and this is we see is a pain point of kubeproxy. This is the second limitation of kubeproxy. If we see from this picture here, like the kubeproxy implementation is complicated, because if you see like the CNI providers which you have in the market, like Calico and Tria, if we want to write our own proxy here, they have to implement their the CNI, like Calico has its own proxy, because which has replaces the kubeproxy. But if you see, they have to copy paste the code from the existing kubeproxy, and which we see is a difficult and very pain right now. The similar situation happens with Calico as well. Like they have their own proxy, they are building their own kubeproxy, but there has to be a copy pasting from the existing kubeproxy code. So this is about the, I want to highlight here about the kubeproxy knowledge which we have in the community. As we know, like very few people in the community understand about kubeproxy and also about the history of what it actually does and all the context. So there is this Twitter example here, which where we wanted to know like why service port has names. So actually, Tim Hawkin has replied this with why the context behind it, and actually like there is a PR also which got created in 2015 and on this. So these are all the like pain points we see and limitation of kubeproxy. Now let's see how these are addressed in cupping, and Rajas will actually walk you through now how the backend is added in cupping.
All right. So now that we have looked at some of the limitations of kubeproxy and how, like, very few people in the community have like context on the history of kubeproxy and things like that. That's like one of the problems we're trying to solve with cupping, wherein we're trying to build a community around it. like both of us are like pretty much new to networking aspects and things like that. So we're trying to break that bridge, to get and to basically cross that and come and contribute to something like cupping. All right, so now let's take a look at uh, how to add a backend in cupping. So we've already looked at this diagram a while back. I just want to highlight that adding a backend takes two things. One is setting up the communication between the server and the underlying proxier through something called as a sync interface on like what the backend, how the backend has to. No problem. How the backend has to um, basically interpret the signal that it receives from the server and then pass it on to the underlying logic of the proxier. And also, yeah, so this is like one part is setting up the communication, the other part is like, the backend logic. Cool. So this is what like a backend sync interface looks like, wherein like, these are all the methods that you have to implement to set up like a backend in cupping. Setup is like one of the most important methods wherein you would initialize your proxier. Then it comes to something like a service listener, wherein we have like set service, delete service. So these things are called when a new service is added or updated or a service is deleted. So it depends on the implementation of the proxy or then how you implement this depending on the mode. And similarly, there's something like set endpoint and delete endpoint. So a set endpoint will be followed after set service and likewise for delete endpoint. Cool. So now let's like focus on the user space mode, right? On how this backend was added in cupping. But before that, we have to know how user space mode works in kubeproxy. So you like just jumping back to the history of kubeproxy and things like that. Like this was like the first mode which was added to kubeproxy, and then we got moved on to something like IP tables and IPVS and things like that. Even though this is sort of deprecated, it's easier to understand the functioning via user space mode and then move on to something like IP tables and IPVS. So that's why we've taken this example. So let's take a look at how user space works in kubeproxy.
Yeah. So we have this diagram of which explains the user space mode. So what actually happens is like whenever any new service is created in the cluster, so underneath there are the endpoint resources which gets created. So kubeproxy is continuously watching the Kubernetes API server for the creation and deletion of all these endpoints resources and the services. So whenever the traffic comes to this service IP to the service IP, there is a IP table rules which gets programmed in the kernel. So the traffic actually goes to the IP tables. If you see here, like localhost 8080, from the IP table, it identifies like which kubeproxy node it has to go back. Like it is doing a switch from the kernel space to the user space, which is actually a kubeproxy pod. And from the kubeproxy pod, it again redirects to the kernel to the appropriate backend pods. So we see here like the packet is actually switching from kernel space to user space and then again to the kernel space. So I think this is I think this is not the preferred method right now. And obviously like we have moved over to IP tables and IPVS. And that's why like we have like see that the user space is deprecated and it is not being the preferred choice right now. So let's see like how this backend can be added in cupping.
Yep. Also a shout out to Arthur. This diagram is from his blog post on like how you can understand user space or any modes in kubeproxy and things like that. Cool. So so these are like the cupping bits, right? Like all the gRPC calls that come from the cupping server to the backend and things like that. And these are all the things that you have to implement from the cupping side. So let's just focus on something like set service. So this is where the kubeproxy logic kicks in. So what we've done over here is basically ported code from kubeproxy user space mode to cupping. Instead of using the Kubernetes V1 API for like services endpoints, we've used like the API implemented in cupping. So focusing back on how kubeproxy does user space, it implements something called as a service change tracker, which has like a current service and a previous service. So this is basically how it can make sense of where the services are added, whether they're updated, and how to keep a track of services. So once you update a service change tracker, once the service is added, and similarly when a service is deleted, then things move to something called as sync proxy rules. So this is where once the service change tracker has been updated, it will try to sync all of those rules. The important bits that happen over here are something like merge service and unmerge service. So this part is responsible for opening that extra port, doing the round robin algorithm, and all of those bits, right? All of them happen in this sync proxy rules. It also opens like a socket and then watches for accepts on the socket, then sees if it can connect to the endpoint, and that is how it kind of adds that endpoints in that round robin fashion. Similarly, for endpoints, like endpoint slices are not implemented in user space mode, but for whenever there's an endpoint added or updated, it keeps a track of the state of endpoints in the round robin load balancer. And then again, like it kind of updates it whenever there's a change. Similarly for a delete endpoint. Okay, so one more thing I want to highlight over here is this is how kubeproxy does implementation using something like service change tracker. This is what is done for IP tables as well, right? Wherein a service change tracker is used. Cupping has a default backend called as NF tables, which uses a slightly different method wherein it takes the full state from the cupping server, and then the backend does a diff on what has changed or whether the rules have to be written or not, and things like that. So a bit of processing is done on the backend part as well. This is another approach that you can take to write a backend in cupping. So if you go into cupping repository, so cupping repository lives in Kubernetes 6 org. There is, in examples, there is something called as user space example cupping, where Mikhail has actually written like a skeleton for how you can do it using the full state model. If you're interested in knowing about NF tables and how it is different from IP tables and things like that, there's like a great video by John Hawley on that. Also, if you want to get some more context around cupping, there's the the in progress KEP, wherein you'll find a ton of context on what all we've been talking over here. Apart from that, Ameem has like a great series of blog posts on how user space backend works in Windows and comparing it to how it works in cupping, right? Like adding Windows user space to cupping and kubeproxy. So this is another great series of blog posts you can take a look at. Also, Jay has another series on blog posts on how NF tables or NFT backend works in cupping. Cool. So I have a demo prepared on how user space backend works, in cupping, and this is sort of pre-recorded. I just recorded it just so that things don't go, things don't mess up at the last moment. So, okay. So like any other Kubernetes demo, it starts with a cluster. So I have a 3-node kind cluster over here, which is running cupping. So, yep. So this is running cupping and not kubeproxy. I got this up using something called as hack test e2e.sh. So this is a script that lives in cupping repository. This is pretty intuitive, wherein you can say, which IP version you want to use, which backend you want to use. And we actually use this script in CI. So if you give a -d mode, it'll not run conformance tests. Otherwise, it'll run conformance tests for you. So what this does is it builds cupping server, cupping backend, depending on the changes that you've done, and then deploys cupping. Okay, so this is the cupping. So cupping is deployed as a daemon set, right? Like kubeproxy. So this is what the cupping daemon set looks like. So you can see it comes with like 2 containers. So this is the cupping server, which is basically listening to the Kubernetes resources. And then there is the cupping backend container, which is listening to the cupping server, right? And then processing whatever signal it gets from cupping server. So this is what the daemon set looks like. Okay. Okay, so what I've done in this demo is that I'm going to play with services and things like that, and watch the logs and how cupping is intuitive enough to debug and things like that. So what is happening over here is that I'll just fast forward a bit. Okay. Okay, so in this pane, I've basically execed into one of the nodes. So the reason I've done this is to look at the IP tables rules which are created. So that is what this pane is going to do. In the other pane, what I'm doing is watching the logs of a cupping pod and specifically the backend container. So this is basically what the logs look like, and we'll see how they change when a service is created and things like that. So in this pane, I'm watching the logs of cupping pod and specifically the backend container. And in the other pane, what I'm doing is I'm execing into the cupping server container and running something called as cupping node log CLI. So what I'm doing over here is I am listening to the cupping server, and I'll get to see what cupping server sends at a node level. So this is basically like a node level view that a cupping backend can see. So whenever the good thing about this node log is it will continually try to watch the cupping server. But when you start it the first time, you can see the entire state of your cluster. You can see all of the services and endpoints, right? So these are the only two resources that are needed by a backend to implement its networking rules. So that is the information that it's providing over here. Okay, so now that the stage has been set and all of the panes have been set up, I'm going to create like a simple deployment of Echo Server and then create a simple cluster IP service for that. So if you notice, the moment the cluster IP service gets created over here, we should see some changes in the node log and also in the cupping backend container. Yeah, so things changed, which is expected. And now let's see like what state we got. So here we are looking at the node log. You can see the new service has been added. Like this is the state that was received by the cupping backend. What type of service is it? It is like, what are the endpoints that the service is running on? Like this is all it requires. And with this information, the backend will do its job. It will, create those networking rules and things like that. We can also see what happened in the backend container. So it got the service change, and then it called something like on service add. So this is basically, it'll move to merge service, and all of the user space logic will kick in. Also, I think I missed out on mentioning that this is running in user space mode and not in IP tables or NFT mode. All right, cool. So now what we can do is we can also remember the node that we had exec into. We can run something like IP tables save and look at all of the IP tables rules that were created. Like this is like a lot of rules, but we can just grep on whatever service name we have, and this is like cool stuff. So these are the rules that are created when this Echo service was just created, by the backend. And as you can see, it's just, this is like a node IP, and it has just opened this proxy port where the round robin will happen, right? So so this is 1096.79 is the service IP, the cluster IP. So any request that comes over here that gets just routed to the node. So things come in the kernel space and they move to user space. Now the routing will happen in user space, and then it'll again point it to one of the pods, right? The backends, and move to the kernel space. So basically this is how user space is working. The other aspect is we can actually curl the service. Here I have tried to curl. I've tried to curl the service on that port. So I'm inside one of the nodes. So that is why the cluster IP service is accessible for me. The reason I chose Echo Server is that it gives me like some sort of information on which backend pod, right, it is routing to. Why this is important is that if I keep on pinging this service according to round robin, it should keep on changing the backend pod. So that is basically what I'm going to do over here. Yeah, so I've been like continuously pinging the service over here. So it is, shuffling from 10.24413 to 10.24423, right? Like if I keep on doing it, this is how the round robin is kicking in. And this is how we have user space mode working in cupping. There's a bit of the demo left in a way wherein I was like, changing the service type from something like cluster IP to node port, and then seeing how that gets reflected. In this case, it won't be a service add, but a service update, wherein, the endpoints have changed, the type of service has changed. And, if we look at the rules, then, the rules have been updated, wherein node port has come into the picture over here. And things like that. So I just wanted to point that out, but I'm running short of time. So I'll just skim through this. And the last important bit that I want to point out over here is that similar to node log, there is something called as a cupping global log. So if I replace this node log with something called as a global log, as long as I can spell global log correctly, see, this is what the cupping server sees, right? This involves all the Kubernetes aspects, all the node names and things like that, and the service and endpoints resources, right? So this is the state that is received by the cupping server, and it filters this out, does whatever processing it requires. It may involve topology computation or any Kubernetes business logic, and then gives like a diff to the node to implement its networking logic. All right, so this is what I had for the demo. And what I'm going to do is, yeah, so these are some more cupping resources that you can take a look at.
Yeah. So as Rajas already mentioned about the few cupping resources, so we have few more here. Like there are like few TGIK and entry talks which happens and which already have the cupping, how it works and the ongoing story of it. So if you're interested, please have a look at it. There is also one blog post by Lars on how to write your own proxier. So if you want to take a look at it, and you can start writing your own proxy. So let's do a quick recap of what we have learned, what is Kapig. And so if you see, like, Kapig has actually like decoupled architecture of control plane and data plane. So what we can do here is, like, if you want to write your own proxier, you can start writing your own proxier from scratch without like depending on the Kubernetes API server, and you can maintain your own fork. So CNI, like the plugins no longer have to sync with your group proxy code. We also see here like the Kubernetes API server has been benefited from like watching the endpoints, and the load is also reduced. So this also provides a possibility for the new anyone who wants to start writing your own proxier, which can be maintained outside of the Kubernetes. So what's next for Kapik? Okay, yeah. So the Kapik team is trying to like the ongoing work and what are the next actions planned ahead. So we are trying to make all the backends conformant. Like we already have the code and it's already in the like in our repository, but we are trying to make like the backends conformant so that they pass the basic test. So the team is working on that. We are also working on identifying like how you can replace your group proxy with Kapik. So if if anyone wants and interested in that, we can talk on that as well. So the team is working on that, and we already have a in progress cap. So if anyone wants to work on that or have any queries, so we can take that look and we can also make it to completion.
Yeah, so I'm running short of time, but I just wanted to give a quick shout out to the people behind cupping. So this is Mikhail. He is responsible for like cupping server and the NF table backends. Jay is sort of everywhere when it comes to cupping. He helped Vivek with IP tables backend. Anusha is also helping with IP tables backends. Ricardo is the one who gave us like the initial IPVS implementation, and then Lars helped on both of these things. Hanumant is helping on IPVS. So Neha is also helping on IPVS. She's also one of the founding members of the cupping CI team. Along with Friedrich, we got like invaluable inputs from Antonio on CI for cupping. Doug has been helping on CI and also helping out Jay on Windows kernel space implementation. Ameem is the one who added Windows user space implementation for cupping. Pear has been helping us with IPv6 support, and I've been helping Jay with like the Linux user space support. So like these are all the people behind cupping. And where to find us? We are SIG Network KPNG on K8 Slack. If you're not on K8 Slack, join us on slack.k8s.io. We have weekly meetings on Fridays and Wednesdays, one in APAC and one in PST. So we also hang out, like, if people are interested on, hacking with us on cupping, we'll pair with y'all and, help y'all out. So, all right, so this is all we got. I know I'm running short of time, but can I take, like, if there's a question, like maybe one or two questions? Yep.
So how does something like a service mesh impact the usage of KPNG?
So I think as of now, we've been focusing more on like the different modes that are there with kubeproxy, and then replacing that with KPNG, right? The next step maybe would be to focus on, like, once we figure out how to replace kubeproxy with like KPNG, the next step maybe for us would be to think about service meshes and how they come into the picture, how Istio and things like that would help us. Thanks for your question. Yep.
How are actually other companies like Calico, VMware, and all of the CNI providers seeing this and participating? Are you seeing some traction of them? I've not been attending the meetings. This is why I'm asking.
So I know that Antria has been using the user space proxy like for Windows and things like that. So if from that front, like we've been getting help from Antria folks as well, like on copying. But I'm not sure around Calico, so I'll not answer that. So yeah.
None of them. I'm asking because I know that there is some problems. So, sorry.
I don't have much context, so I'm sorry. Cool.
Okay.
All right. Thank you, Rashis and Neha.
Thank you.
You know when we come and play dub combination. Emergency.
All right. Up next, we have Katalin Yora from FikaWorks, and he's going to talk about how we can build tech communities inside companies. Let's give him a nice welcome.
Thank you. Hey, hi everybody. Do I speak loud enough for people in the room? Okay, perfect. Okay. So I'm an engineer and I am a consultant as well. And for 10 years or so, I'm always in one way or another trying to build communities. It's either around on the technical side in the companies I work, around the people, around my neighborhood, and I think there's some magic happens all the time you put people together. And those practices, I want to try to take them everywhere I go. So today I want to talk about building tech communities inside companies. This is the first step. It's an incubating step for people to actually go out and contribute to open source and come here on stage and talk about presentations, about what they do in their company, about starting contributing to open source. They need a safe place to do it. So building a tech community inside a company, and especially talking here about medium and large size company, is the first step for them. So I want to show and tell about a framework for actually doing that and introducing it in every project we're actually working on. So I'm part of the FikaWorks collective, probably the only company you haven't heard of from here, because it's not really like a company, it's more like a community of freelancers trying to work together to build stuff together. And I'm also doing some community work around Docker in Netherlands, experimenting as well with the podcast, and I volunteer and I organize as well different conferences. I'm here talking here because also I was rejected for KubeCon, which is an irony because I also was part of the CFP, but I didn't review my talk, of course. I was for another track, and I'm happy to see here a lot of good talks, which were supposed to go to KubeCon, but didn't manage to make the cut. So I also built some stuff for around the tutorial for Kubernetes, and here's my LinkedIn profile and Twitter handle. So let's start. How does a medium big company looks like? Yeah, you have different units, different product units, or how you want to call them, tech centers, tribes lately, and there are some connections between them, but they are not fully connected. They are still kind of siloed. Even everybody is still doing agile, but they are still kind of siloed. So the flow of information and the way tech engineers talk to each other, it's still kind of siloed between their work relations. So why is this happening? Why do we still have the silos? Yeah, we have the silos at different levels. So for example, everybody's moving to Azure DevOps, and it's a great tool, but then every organization in every product unit, every tribe will have their own organization in Azure DevOps, and it's not shared with everybody else. So you cannot have access to see how they build the pipelines. You cannot see how they actually, what projects do they have, how do they do their contribution to, I don't know, whatever, how they are running stuff in Kubernetes, how they are doing deployments. So the tech engineers are not connected because they cannot get to the source code in some cases, yeah. that leads as well to duplicate work. And if you're jumping to help a company to introduce a new technology, you're gonna see when you start talking to different people in different departments that they build the same stuff. Yeah, it's a lot of duplicate work everywhere. And teams actually have faced the same problem. So they are not a community. Yeah, they are still isolated. Yeah, they isolated because of the way their business is organized, what products they do, how what dependencies are between their teams, who's consuming what from other product. And then the COVID situation happened, and a lot of companies had to start working as well remote, and this didn't really help. So they managed to still do their business as usual, but it didn't really enhance the communication between them. And then you come into the picture, yeah, and you, meaning like a person trying to introduce some technology, meaning like a DevRel from an external company trying to promote some tooling that the company is interested in, or maybe what it's called now, a customer success person from a vendor trying to work with that company to make it happen, right? So it can be inside the unit or it can be actually outside. So I kind of like walk you through a framework that will help you to build a tech community and help make it thrive in that company. So it will actually help you adopt it in a way that will actually work after you leave. For example, if you're joining as an internal engineer, if you're a manager trying to bootstrap something in there, or if you're still an external third party trying to make something useful for that company, for that customer. So why would you like to build a tech community? Well, so I put a list of things in the line. Of course, you want to introduce successfully technology. Huh? So assuming you're, and I'm gonna base this on an enterprise in Netherlands that started to adopt Kubernetes, and we saw that at the moment of introducing Kubernetes in one of those units, yeah, we are not the only one doing it. Yeah, there were other teams, other departments doing the same thing, but they didn't know. Engineers didn't know about the other initiatives, how things started, what worked, what didn't work. So successfully introducing technology will actually bootstrap the knowledge of the entire team. It will also remove the duplicate work. And for example, we spoke also on the same enterprise, it was Elasticsearch was being used. And we learned from the vendor that we thought there are 3 teams using Elasticsearch, but there were like 10 teams using Elasticsearch. And we didn't know about that. So we learned via the vendor that, okay, there are other people doing that, and don't do that because it will not work because that team tried it. And it's going to save you like 1 sprint of wasted kind of spike or whatever you're calling it. It will help sharing knowledge between the teams as well, because fragmented work will actually not help that company achieve basically a successful adoption of that technology. Also, you will see if things are starting in different places at the same time, that they will architect something that will work for them, but it will be very hard to be consumed by another team. Because they don't think from the beginning that this is going to be inner source, it's going to be consumed by the entire company. They just think about, okay, how to make it work here so we can quickly deliver this because we have a very big backlog and the business is putting pressure on us. And they don't think about, okay, maybe the other team is actually needing this thing as well. And I need the other thing that the other team is building so I can use it, so we can combine those things, like build it modularized so we can all leverage that. It will enhance as well real collaboration. And at the end, yeah, it's if you're as an external, yeah, you don't really care too much about the tech brand of the company, but you do care about success user story, right? So if you have that company talking about, okay, we implemented this and that, and we introduced this Kubernetes distribution or this tooling, and the customer is actually, your customer will start talking about it, it has a different value, yeah? So we as engineer, we look not necessarily on the Google blog to see what customer used and what was the success story of that customer on the Google blog, but we are gonna check what an engineer from, I don't know, an end user company will say on Hacker News, or will post something on Reddit, and then it's the genuine story, yeah? Like how we fix something in a way that help us enhance the open source ecosystem. And this will facilitate recruitment. It will help as well build a brand for the company itself, and it as well, you as a vendor eventually, it will give you like some boost, like, okay, this happened with our product, and this company did it in this way. So it can help different actors of the ecosystem in different ways. So this is me trying to introduce Kubernetes in one of those units. And I realized, okay, we don't have it here, but there are other departments that are already busy with that, yeah? We're not only doing it with that Kubernetes distribution, there are people using other Kubernetes distribution, there are people using other clouds as well. So in the end, they will reach some backends for that enterprise that I will need that knowledge, right? So even if I'm using different things, I will need that knowledge. Will that work? Will that approach fail? So I can save some time. So starting to look for early adopters of a technology will be the first step. So you can do it if you're joining the company, or if you're external, just search and ask people. Search, intranet chat platform if you have access, wiki. Look for areas where people talk about that thing. Can be internal and external events as well. So you'll be surprised, but even in companies that don't do open source, you still have some individual heroes here and there that are passionate about it, that talk, that go to conferences, they do it individually. Maybe they do it on their own, not in the name of the company, but there are still people there. So try to find those people and see if you can establish contact with them. So the next step will be trying to put them in touch. So you're going to establish contacts with one person from here, from that department, from the other department, but then try to put them together. So you'll see that when you do some informal events, people will show up, will start talking about their experience, what worked for them, what didn't work for them. You can go in different formats as well. Yeah, you can organize face-to-face events if possible, if people are in the same region. Drinks for like large office hubs. If you have like 1,000 engineers in Amsterdam or Berlin or Dublin, just try to organize some drinks after that and talk about Kubernetes, and just in a relaxed manner, and see how things work. Once you kind of establish these things, you can try to facilitate a first official meeting, an event. So you can try different approach, and I try different stuff in different companies. You can invite an external speaker, for example, and that will show you who's actually interested in this topic in this company. So you'll be surprised to see like a lot of people will show up just because you have an external speaker, experienced speaker that they know, they want to learn, they want to exchange knowledge with him, and they will show up. You can do a show and tell. It's still kind of informal, but at this stage, and people will be willing to show their code. It's not NDA, so it's just between them, between departments. They're still okay. Yeah, some people are proud, some people hate their code, so they want to get feedback. So there are different ways on actually facilitating and trying to build some bonding. And just start small, one presentation. If you don't get anybody excited, you can just do it on your own. Yeah, you can just talk about the stuff you want to implement in that unit where you're located, and your challenges, and what do you think and ask for feedback. What can I do? Did you try this? Did it work for you? Can I do it in a different way? Just be humble and try to get feedback. So once you start it, you need to be there and somehow try to lead it. So I don't know if you know this guy trying to dance. So it goes like this, yeah? So you need to start humble, try something, and And in the beginning, you need to be there. So you need to just put yourself in front and try to lead it until you actually get some signs that there's some possibility to build a community around it. Yeah, it may be the case that if you're in a Java company and you try to introduce Rust or something or WebAssembly, yeah, maybe it will not fly if 99% of the people are just doing Java. But if you're looking to introducing a new technology that will benefit everybody, there's the chance that some other people are thinking of doing that or already doing that in some different ways. So try to see who are the people who are next to you and can actually help you to promote it. And the early adopters, the internal DevRels, kind of like will join you, and it will not make it look stupid. So you're more people, then it's becoming a movement, right? As well, you can try to get support from business. You don't necessarily need to get support for trying this. You don't need for sure to get approval, because if you formalize it, then people will not show up. And I saw it in for example, my current project, they were trying to push from top to down, kind of like internal DevRel project, which didn't fly. So people were not excited about the technology. Some technologies which are sold by the vendor at high level, like CTO to CTO, like playing golf and stuff, and then the next day okay, this is our new platform from now on, and you need to talk about it internally in your departments and make it fly so we can remove the old platform. Didn't work out, right? So people don't get excited if they are actually excited. If it's pushed from top down, it's not gonna fly. So it needs to be genuine. You need to have actually people involved in working on it and talking about it and actually making something that really is a community. Because if it's being pushed from top down, it's not a community, right? Okay, so everybody's dancing in the end. We didn't manage to get so many people for the Kubernetes community that the Bootstrap, but it still was pretty good. Hopefully was not needed, right? I know the FOSDEM dance, yes. But if I'm gonna go to one of the next meetups, internal meetups, because it's still happening, maybe I can do a dance. I should. I don't know the FOSDEM dance, but we can come up with something. Do you have something? Do you want to start something for rejects? Okay, we can think about it. We can think about it. So once you set up the ground, try to build something more regular. And depending on the schedule of the team and where do you get people? Yeah, are they in the same time zone? Are they in the same location? Should it be in the morning, in the evening? Should it be like half an hour, 1 hour, 2 hours? Informal, like show and tell. Just try to come with a structure which will work, and it will keep people coming back to the next event. And try to grow it organically. It's a cliche, but for communities this works. So people will talk about it if they're interested, and it will bring other people. So if say, okay, we are gonna talk about, take the example of Kubernetes, how do we do deployments of Kubernetes? If you have people, and you know this is the topic for the next event, people will think about it, okay, do I have questions or do I have something to share? No, but I know that person who's not part of this thing, but I'm gonna try to bring him here, and he will either talk or put interesting questions or will answer some interesting questions because he's already doing Kubernetes in the other platform for 1 year, and some stuff worked for him, some stuff didn't work. Try to make it work for the people that are actually part of the community. Yeah, next step, if this is working, of course, you need to start to formalize it. And whatever the company is using, Wiki or Notion or whatever startups are doing now, or big enterprises are trying to adopt as well, just make it there. Make it visible that when people are searching for Kubernetes or eBPF or whatever you're introducing now in your company, they will find, okay, there's a community there, they meet every month at this hour, and this is what they discuss previous times, and this as kind of like slides or demos or whatever, or recordings. Yeah. Try to put the people in touch so you can have so they can have asynchronous discussion as well. Slack, Teams, whatever they have, Skype, whatever companies are doing. Company events as well. Start talking outside of your small bubble, because all the companies are doing tech events. Try to go there. Try to put people in front. Try to just show that you're actually a community. You're thinking about a problem in a company in a general way, and you try to fix it for everybody. That's very important. As well, if you have internal blog, just start talking about there so you can get more traction, and you see like newcomers in the company, which people are leaving and joining all the time, so they can find you in an easy way. Next step is around generating content, and what I saw is after you start to build a community, people will build better README file for their projects because they know, and this will be useful also for other departments. Yeah, this is not something only for me. It's a problem that the entire company has, and it can be inner source. Yeah, so other people can consume it. Hands-on materials, wiki pages, presentations internally, so that people can consume the stuff you're doing there, and the business will see the value as well. Yeah, and it will start to support it. It will allow people to spend more time on it, and hopefully we're going to the next step when people will start to contribute externally outside of the company bubble and going outside in the open source area, try to contribute to project upstream, start blogging, doing presentations, coming here and telling how they solve that, and like this Fortune 500 company solve this problem in 3 months in that platform. Yeah, so you want to have some genuine stories, and how real people and companies like yours actually fixed and implemented something, and all the challenges and all the stuff. So it's not kind of like vendor marketing, sales, pitchy stuff, which is kind of, it's good as well, but then it's not so authentic, right? So people want authenticity, and you can achieve that by just allowing companies to build from internal their communities. Yeah, the external part is very useful for recruitment, and everybody's challenged now with finding good people. So if you have kind of like good content, it will facilitate recruitment, because people, and you're going to be at KubeCon, you're going to speak with people from different companies, and you want to join a company that have a nice culture, they share stuff, there are conferences, they have nice people to work with, you have people from where you can learn. So it's stuff which is compounding all the time. So step-by-step guide, the most important slide. All the stuff I talked about until now. Of course, just want to stress one thing: you cannot build a technology on top of every community on top of every technology. Yeah, you need to have some adoption. So if you're like one person kind of like fan or something, it will be hard to actually build something around it. Yeah, you need to have something that will be useful for more people, and if you have more people excited about something, magic things can actually happen. 2 more things I want to stress out. So what happens when we're actually having kind of like a community discussion in a company? So you see, everybody's starting to talk with everybody. So you have like this kind of peer-to-peer collaboration. If something happens here, you'll hear about it in a different department. If something is good or like a problem happens in another department, it will propagate very quickly to everybody. So people will actually take action on that very quickly. So this it will make the company really become very agile, yeah, because it's not moving from that Spotify tribes model where actually things are very siloed into a really kind of like agile distribution of knowledge. And another thing, we know that, community, engineer talk to engineer. Yeah, you're here at this conference, you're gonna go to KubeCon, you're gonna talk with somebody who implemented some other technology from Google, from Microsoft, from Red Hat, from engineer to engineer directly, yeah? So there's no red tape in between. You can have an honest conversation with everybody, and this will allow you to actually go to the source of knowledge very quickly. What happened in a silo company where you kind of like don't know who's doing what, and the communication goes like this: engineer talks to tech lead, then to manager, manager to other manager, to the tech lead, and then to the engineer, and after 2 sprints you manage to get a 20-minute slot with an engineer to ask him a question, and you figure out, okay, this is actually not relevant for me. I waited 2 weeks for nothing. Shall we try it with other department? And then the flow goes like that. Yeah. So a community will actually remove all that red tape between engineers. So it will allow them to actually collaborate. And I saw it that people start to help each other very quickly. And yeah, one last remark: if you want to make it happen, just own it. So we're all changing companies. We're moving from one job to another, and what do we leave behind, right? So I'm here. I'm going to a company. I'm implementing Kubernetes. I'm doing containers. I'm doing eBPF, whatever. I'm leaving in 2 years. But okay, what's happening with that project? Do you still have people interested in the technology? Do you actually have something useful after I leave the company? Or after I implement something as a vendor, in 2 years from now, yeah, I'm still gonna hear from that company that, okay, we started contributing to that project. We have some presentation. We took that project into a new direction. Yeah, just try to do more, and don't wait for approval or for managers to actually make it happen. Just go facilitate it, and yeah, there's nothing you can actually lose, right? What's the worst thing that can happen? There's nothing. You just met some people from different departments. You try to push people outside of their boundaries. You increase the open source pool of engineers that can actually contribute. That's the story I wanted to tell. Thanks. You still have time for questions in case there are questions?
We do have time for questions.
Cool.
What would you say your biggest challenge is when it comes to actually building a community?
Well, the biggest challenge is finding the initial people that can actually support you. Because depending on for how long you're actually going to be with that customer company, yeah, just don't assume you're going to stay there 20 years and you're going to drive it. Yeah, maybe you're not the right person to drive it. Just find some people and try to build some excitement and see if you can actually build that excitement. If it's not going to fly, it's not going to fly. Because after 1-2 meetings and after meeting some of the people, you'll realize if you can actually have something that will last, or it will just, when you're leaving the project, the company, it will just go away with you, and it will be just a nice story, and people just forget about it. So just trying to find those initial persons that have some spark. Some of them are not used to contribute to open source, to collaborate, to go outside of their comfort zone. Just try to work with them and motivate them to make the first step. So it's the first, I think, the most important thing.
Have you ever started a tech community and then left and been sort of heard about how it's going like a year later and find out how it's changed?
So we have Nick here, who said, when I told him like, okay, I'm gonna talk about building communities, and he said, okay, the stuff you started in Rabobank, it's still happening, it's still there. People are still there, they're still meeting. So I was like the biggest achievement for me for this kind of stuff.
Yeah, that's great. Who's next?
Hi, a really good talk. I was wondering if you ever had trouble to convince management of the need to give that time to build a tech community, and how you did that.
Yeah, so that's why I said don't wait for approval from managers, just try to build it. Yeah, managers are always looking, okay, deadlines, and okay, we have a roadmap, and they staff engineers time for next 3 months, so they don't have any kind of slack time. So that's why I said try to build it on the side, and once you manage to get some adoption, then the manager will support it. If they see some traction, they will support it. But in the beginning, it can be tricky. So if you just go and pitch it like, okay, you want to build this and that, you need to show something. So if you go with something, just start a bit more informal. It will also make it easier for people to join, because then it's not like something they will need to put at the end of year review or something like that. So, okay, we tried to bootstrap that community and failed. Okay, then you're not getting the bonus this year, right? So just try to start it small, and then when you get some traction, you can push it towards the managers.
Thank you. It's very interesting talk, and most likely I will pick your brain more after the talk. Are you aware of something called Brodsky ADKAR model for change management?
No.
Okay, so basically, you went around it. It's awareness, desire, knowledge, ability, and reinforcement. So, and one thing that is problematic with this model and the way you described how you build community is the feedback. How did you handle feedback, and how much good feedback did you have? And how do you encourage feedback from the community?
Yeah. So, for example, when you're doing the meetings, you can regular meetings, you can schedule the format in a way that will allow as well Q&A and feedback at the end of the session, right? So, okay, what shall we discuss next time? Are you making? Is there value that you take out of it? The fact that people are showing up, and also I see it as well at the meetups that I'm organizing. If people show up, it means it's being value to them. If you see people here every month coming back, it means it's something for them there. So if they show up, I think that's the best feedback that, okay, it's going the right track. For businesses and for, yeah, I can see it. I mentioned, like, see the improvements in the README files for the Git repos. People start to structure code better, create modules in Terraform, and so think about, okay, consuming it outside of my silo. So kind of like you see them, not necessarily, I didn't ask explicitly for feedback, but people showing up and improvements in the projects were like a thumbs up for me that is going the right direction.
All right, one last question.
Thanks for the great talk. You've briefly touched on the changes in communication style, which I find very interesting. Did you encounter any? Yeah, exactly. Did you encounter any friction or pushback when that change happened?
No, because we introduced as well separate channels for like the community, and the discussion was happening there. So it's not going anymore via managers. So engineers were fixing it directly before actually it was becoming a problem that need to be reported to the tech lead or the business people. So they kind of like cut the red tape, and they start helping each other as a community and not looking anymore at the business layers, right? So yeah, it's the power of the community that just make the thing happen. The manager, I think they were happy. Because we're fixing things for everybody, right? So we're thinking fix things for everybody faster than before. So save them some time as well, and yeah, things were moving in the proper direction.
All right, thank you very much.
So thank you.
So you can get some snacks, get some fresh.
come to break down oppression, rule equality, wipe away transgression, set the captives free. Exodus, order, movement of the people. The people. Well, all right, we're jamming. I wanna jam it with you. We're jamming, jamming, and I hope you like jamming too. Ain't no rules, ain't no vow. We can do it anyhow. I and I will see you through. 'Cause every day we pay the price. We're the living sacrifice. Jamming till the jam is through. We're jamming. To think that jamming was the thing of the past. We're jamming. And I hope this jam is gonna last. No need to stop us now. We need to beg. No, we won't gonna last. No need to stop us now. We need to beg. No, we won't bow. Neither can be bought nor sold. We all defend the right. Judge our children must unite. Oh, life is worth much more than gold. We're jamming, and we're jamming in the name of the Lord. We're jamming. Look out. We're jamming right straight from your holy Mount Zion. Holy Mount Zion. Just seated in Mount Zion. It rules all creation. We're jamming. Up to our war. We're jamming. War. We're jamming. I wanna jam it with you. We're jamming. And jam them up, you're jamming too. Jam knows a matter of pride. The truth again.
However you want it. Oh, all right. So welcome back. Our next talk is going to be presented by a cool team from Red Hat, including Mana, Sid, Yuri, and Rose, who are going to talk to us about a very long subject that I don't remember. I'm sorry. But let's give them a warm welcome.
Hi, everyone. How are you guys feeling today? Good?
Good.
Okay. Thank you for coming to our presentation. Yes, I'm Mana, Sid, Rose, and Yuri. Our other colleague couldn't be here, Sundaria, but she helped us with everything here. So quick shout out to her. So thank you for coming to our presentation, L5 Operator from Zero to Autopilot, exploring Kubernetes operator capability levels. So how many of you guys have heard about operators? Awesome. How many of you guys use operators? Cool. How many of you guys have made operators? Wow, awesome. So you guys can teach us, right? I'm just kidding. So operators, what are operators? So we'll try, it's hard. I think it's hard. Operators are hard, but we'll try to break it up and explain it as best as we can. So what is an operator? An operator can be thought of as a Kubernetes native application that extends the functionality of Kubernetes. So it's a pattern Kubernetes that uses custom resources and controllers to manage applications in a cluster. And so a controller is a control loop that watches the state of the current cluster and tries to bring it closer to the desired state that we declare in our custom resource. And so right now, operators in general have different maturity levels, right? And so the capabilities can range from basic installation to complete autopilot, with autopilot being our goals for operators, right? We don't want to do anything. We just want to sit back and let it do everything for us. And let's see. And so in the operator framework explains what autopilot. Oh, it is. The operator framework explains the capabilities models of operators really well. And so operator framework is an open source toolkit that is used to manage operators in a more effective, automated, and scalable way. Like I said, operators come in lots of maturity levels. So this framework really helps guide us as to what levels, what features each operator, what features users can expect in each operator, right? And so the 5 levels are basic installation. Level 2 is seamless upgrades. Level 3 is full lifecycle, backup, restore. Level 4 is deep insights with metrics and alerts. And then level 5 is autopilot, meaning auto scale, auto heal, auto tune, and it's able to detect abnormalities and let us know about it if it deviates from the standard performance, right? It can automatically fix it, or it can alert us to come and fix it. So currently on Operator Hub, there's only 70% of operators that have level 2 capabilities, and only 5% of operators that have level 5 capabilities. So in this presentation, we're hoping to enable you guys to be able to create operators with greater capabilities, as well as add more capabilities to any existing operators out there. Okay, so first off, we're going to start with level 1. Level 1 is basic installation, automated application provisioning, and configuration management. So this is our Operan, the application that our operator was created for. We're going to do a quick look at this. This was created with a React front end and a Flask back end with a Postgres database. It'll show up.
You can just look at the screenshot.
Sure. Okay. Well, it's a really cute little application for pad adoption here. And so for our operator, it's written in Golang, so it's a Golang-based operator. We utilized Operator SDK to orchestrate our operator, so it came with lots of things out of the box. Operator SDK is a framework that uses the controller runtime library, which helps simplifies the building, testing, and packaging of operators. And then Operator SDK, you can also integrate it with Operator Lifecycle Manager, OLLM, to help streamline the packaging, installing, and running of operators on a cluster. And also, Operator gives us a lot of stuff, right? So if you have a Go-based operator and in the cluster you have Prometheus operator as well deployed on it, it sets up metrics for you automatically. And so to create our L5 operator into a level 1 capability operator, we had to think about the requirements of our particular application and the desired state of our application. So we decided we needed the deployment, the service, the route ingress, the Postgres database, and a job. For Postgres database, we used the crunchy Postgres operator. So it came with a lot of stuff out of the box too, and it did most of the heavy lifting for us. And for the job, we needed that to seed our database before our application ran. And this is just a quick diagram of all the things our application needed. Let's do, there we go. Yeah, so this is a quick diagram of all the things our application needed. Text is quite small, but it's deployment, ingress, the services, and secrets, and all of that. And so next up is the custom resource. So here is a custom resource is an object that lets you extend Kubernetes, right, capabilities, and adding any kind of API object that's useful for your particular application. So the custom kind that specifically pertains to our Operan Bestie application is the kind Bestie. You see here we specify a size of 3, and we have the image in there, and max replicas, and the version. The version, okay. So next up is the controller, right? So in our operator, we need the custom resource and the controller. So again, control loop, controller watches our desired state, and it tries to get it to our defined state in our custom resource, right? Okay, so once the controller is triggered, then it does our reconciler function, right? So here is a quick snippet of our reconcilers. We cut it up into little sub-reconcilers. So once an event occurs and something happens, then it goes through this reconcile function and goes through each sub-reconciler. You see the Postgres, the seeding, the job seeding, the deployment, service, the horizontal pod autoscaler, and the routes. And here we're going to do a quick demo to show you guys. I can get it. Right. Okay.
Not presenting?
No, she's just finding her mouse.
Yeah.
Oh, you lost it. It's on the left side.
Went to the left side. Okay, it's so small. I'm like, where is it? So our operator is on Operator Hub. So all you have to do is search it up on Operator Hub and L5 operator, declare the namespace you want it installed in. And yeah, it'll start loading super fast. Just kidding, I fast forwarded it, so it's not that fast. You might have to wait a bit. But yeah. And so after that, we're gonna check and see if the operators are there. Our operator is dependent on Crunchy Postgres operator, and so you'll see that the Crunchy Postgres operator is there as well. And then we're gonna check and see if everything's being installed right. Then you're gonna see the Postgres pods being installed, and are seeing the Postgres Postgres pods, and then you'll see the job being processed, and then you'll also see that the job is only the deployment is only processed after the job is done because we specify that in our reconcilers. And yeah, so the job is completed and now the deployment is running. And the job only goes once the Postgres cluster pods are all good and stuff, right? And so now we're gonna check and see everything is there and available. You see our services, our pods, our deployments, our replica sets, and our routes. And then we're gonna double check. We do have our route. And we're going to take that to the browser and take a look at our application. Here's my mouse again. Yay, and it's there. So now we have level 1 capabilities. We're able to install our operator. We're able to install our operator. Level 5 operator now has level 1 capabilities. It has the controller and the CR, the custom resource, and it can automatically provision and configure all the resources that we need for our fast application upon installation. And so next up, Sid will be talking more about the capabilities of level 2 operators and how we brought level 5 operator from level 1 basic installation to level 2 seamless upgrades. Okay, take it off, Sid.
Thank you, Mana. So everyone, my name is Sid. I'm going to talk about level 2 and level 3, since one of our speakers couldn't make it. So what is level 2? Level 2 is basically described by the operators framework as the capability of your operator to do sort of patch and minor upgrades for both your operand and your operator. So why do we say this? There's 2 layers to it, right? There's the operand, or our sort of Kubernetes native application, that's managing our secondary application, which is Bestie. So the way that we roll out updates to the operator and the operand are slightly different. The operator sort of versioning is handled by the operator lifecycle manager. So whenever you publish a new version of your operator, it gets rolled out to all the users or all the clusters that have this operator installed, and they can choose whether to allow the upgrade or not. In this presentation, we'll be talking about the operand, or our application, and managing its version. And we have sort of a theme for this level 2 and level 3 capabilities of the operator. It's that it's basically a free lunch. Economists like to say that there's no such thing as a free lunch, but in Kubernetes, you get a lot of stuff for free. So we're kind of leveraging that in our operator to get our sort of first free lunch. Our first free lunch is basically our application uses a deployment to run the workload. And in order to deploy or roll out minor updates to it, all we have to do is update the deployment. So when we're talking about operators, we have sort of custom resource, and our custom resources can be thought of as the interface that we use to interact with our operator and application combination. And our interface exposes a few different parameters that we manipulate, so the deployment size, the version, the image we use. And that's how, sort of, in a simple way, you can have the level 2 capability, right? You basically get it for free. Continuing with the theme of the custom resource being the interface of our application operator, we also have a status field in our custom resource that shows us the current state of what's happening to our application and our operator. The example here shows us that as soon as we update the version, it's going to show us, the version being rolled out. So we can see that, there's one new pod spun up with a new version, and the other pods are going to come up as soon as, as the deployment progresses. So all this is, all well and good. We say level 2 seamless upgrades, but there's actually conditions apply. Level 2 is seamless for minor versions where, there's nothing fancy happening. And one of the scenarios where we could have a problem while rolling out an update is if there are sort of incompatible changes between versions. So say we're rolling out a new version, and that version applies some migrations to the database. This could potentially cause some disruption as the older versions are not compatible with this new database. And in order to handle this sort of situation, we need a little bit more sophistication. We need to get up to level 3, basically, to kind of handle it, as seamlessly as possible. So that brings us to level 3. Level 3 basically talks about more parts of the lifecycle, specifically backups and restores. So in order to sort of not be have any disruption, there's a bit more orchestration to be done, and we kind of build up to that as we go through the level 3 capability. Continuing on our theme of free lunch, this is our second free lunch. We're consuming the Postgres operator, and Postgres operator does level 3 for us, essentially. So how do we consume the Postgres operator? We'll look into that. But the Postgres operator is essentially a database as a service, but it's within our cluster. So it's a very mature operator, and it can do all the things that full-fledged Postgres cluster can do. It can autoscale, it can do backups, it can do recoveries, and all of that is sort of managed by the Postgres operator. And our operator kind of consumes it. So we kind of leverage it as and leverage its capabilities, and kind of it levels up our operator's capabilities. So when we say consume the Postgres operator, there's sort of 2 parts to it. The first part, as Mana demonstrated, is that OLAM automatically installs it since the dependency, and we specified it as a dependency. And the second part is we kind of use it, so we kind of manipulate the custom resource that it's watching, and we get stuff out of it. So just to quickly walk through, what the process looks like, we have an example of the Postgres cluster custom resource. It's like any other custom resource. It has a spec, which has a whole bunch of options. We won't look at all the options. We'll just look at a subset of the options. We're interested in backups. So in terms of backups, the Postgres operator is fully featured. It sets up write-ahead logs for you, so you can do point-in-time recovery. It sets up, it can potentially do scheduled backups, it can do on-demand backups, and it can transfer those backups off-site. It can do partial backups and full backups. And it can also define a retention policy, so you don't fill up your storage and spend too much money on storage. So the example of a simple way to consume this functionality from the Postgres operator is to add an annotation to this object. And the way that works behind the scenes is that we use the Kubernetes client that's provided by controller runtime. We fetch this object, we edit it, add this annotation. As soon as we save changes, so we push that to the Kubernetes API server, an event is generated, and the Postgres operator is watching for all events that occur, or changes that happen to this Postgres cluster object. And that's what triggers its reconciler, and it goes ahead and does all the things necessary to make this backup happen. So what about restores, right? That's the next part of the lifecycle. Restores have a few issues, and that kind of brings us back to what we were talking about at the end of level 2. Restores have the potential of causing some disruption, and one of the ways that this happens is during the process, there might be some incompatibility between the application version and the database version. So there's sort of many strategies to go about this. One of them is always roll forward, always make sure the next version is compatible. The database changes done by version 2 is also compatible with version 1. Sometimes developers might complain saying, oh, we don't want to do this because it's extra work for us. We don't want to think about making sure things are compatible. We just want to do our changes. We want to have a high velocity, get the features out. So there's sort of more ways to kind of run it, right? One of them is don't worry about the service disruption. Just take it, tell the users, wait 5 minutes, we're gonna do a change, and then let them get the new version. That's one way to do it. So if you go with this approach, and say we want to roll back to an older version, and there's sort of disruption involved, all we have to do is kind of use one of the many backup features or restore features that the Postgres operator has. And this is an example of how you would do a point-in-time recovery. So it involves sort of manipulating the Postgres cluster object, so adding some information about what time you want to roll back to, and it's triggered by editing the object and adding an annotation. This works exactly the same way as a simple backup. The Postgres operator sees this change, it triggers the reconciler, and it makes sure it does an in-place rollback, and it makes sure your database is rolled back to this timestamp that you specified. So this is kind of assuming that there'll be disruption, but there are more ways to kind of avoid this disruption, right? The general approach would be clone the existing database, spin up a new instance of the app, do disruptive operations. Once everything's good, you switch the traffic over. So this is sort of like the blue-green or the red-black style of deployment. And there's sort of many ways to go about it, and the operator can kind of do it for you. And the way that it would go about doing that is doing the same 3 steps, right? So it would create a new Postgres cluster, and the Postgres operator has this feature where it can clone an existing database. So all we have to do is create another Postgres custom resource, Postgres cluster custom resource, and specify the old database as the source. And then the Postgres operator will go ahead and clone the database for you. So now we have a database. The next step is to set up our new version of our application. And our application refers to the Postgres database or the Postgres cluster object with a sort of predictable name. And that's how it knows to use the sort of older database. So as soon as you spin up this new bestie stack with a specific name that matches with the database that we've just cloned, we have like a complete sort of copy of the application pointing to the old database. So at this point, disruptive updates can happen. The users are still using the old version of the application. Everybody's happy, kind of thing. And then once you're happy with it, all you have to do is switch over the traffic. So this flow is kind of common at this point, right? Everybody's doing it, but there's always some sort of CI/CD tool chain or some sort of extra stuff, either manual steps or some sort of intervention required to make this go smoothly. And the advantage of using or packaging this with your application in your operator is that this would be available through like a one-click experience through the operator hub. So you would go to the operator hub as Mana demonstrated. You would click on L5 or whatever your operator is called. It would behave like an application. It would be installed in your cluster. It would be able to, you'd be able to interact with it using the custom resource and have all these features out of the box as an end user. That's all I have for level 2 and level 3. So like we said, many free things. We just need to sort of put stuff together to essentially package it in a way that's easily consumable by end users. And that's kind of what we're kind of aiming for. Next up, we have Rose, and she's going to talk about level 4.
Hi, everybody. Oop, it's loud. Hey, everyone. My name's Rose, and I will be presenting level 4. Let me get this. Let's see. Here you go. And so life is full of surprises, but for everything else, we have Prometheus and Grafana. At this point, as Manan and Sid alluded to us, we already have a level 3 operator, and we have seamless upgrades and full life cycle. If I can, yeah, there we go. So what else can we ask for? Well, a lot more. So we have these guardrails built around deployment, so we'll never see if our upgrades are failing because we always have a website running. So what we have to do is we have to manually, when we upgrade, we have to manually figure out if the upgrade worked by looking at the pod status or actually opening up the, going to the website. So we don't want to do that. We want to be able to know when our upgrade is not working. So for example, if somebody typed in a bad version or a bad image or an image in the repo is no longer working, we want to be able to know this with an alert or something on the dashboard, maybe with Grafana. So this brings us to level 4, deep insights. And the definition for deep insight is metrics, alert, log processing, and workload analysis. We're going to be looking at metrics and alerts. So we want our operator to set up full monitoring and alerting for the operand. We want to expose metrics about its health, about the operator's health, and we want to expose the health and performance metrics about operand. And we want to aggregate all the metrics using Prometheus and visualize it using Grafana. So the next few slides, what we're going to do is we're going to see how to expose metrics in the operator, and we're going to create alert rules, which will create alerts, and then we're going to show a demo of how all this is put together. Okay, expose operator metrics. First thing you have to do is sort of like the kitchen sink things that we have to do, administrative. We have to create a service monitor. We have to, first of all, service monitor describes the set of targets to be monitored by Prometheus. So for bestie operator, we needed to create a service monitor for our operand. Does anybody know why we don't need to create a service monitor for the operator? And Mana kind of said it earlier. It's because the operator framework creates all that for us already. So there's already, when you build it with the operator SDK, you already have the service monitor turned on. So another thing what I had to discover is that you need a service monitor within the namespace that you're monitoring the service. And so those two things. The next thing, here's an example of the service monitor that is watching the bestie operand. And pretty much the YAML manifest looks same for every service monitor you want to create. The only difference is for the endpoint, that port, you want that name to match to the port name for your service. And then the selector match label has to match the service label. And for this, we also need the operand to expose metrics. So I want to show you if I can do this. Where's my oh, good. Okay. And now, so the operand is exposing metrics from here. So this is live data. And for best practice, we always want to prefix your metrics with the name of your operator. So in terms of when you're in Prometheus, it's easier to find the metrics. There you go. Another thing we have to do before we can actually work on the metrics is that we have to grant permission to Prometheus server. So the operator framework uses KubeBuilder to scaffold the operator. So the metrics are protected by the Kube RBAC proxy by default. So because of this, we need to create a cluster role, and we also need to create a cluster role binding. So we're binding the service account, which is called the Prometheus KAS, in the OpenShift monitoring namespace. One more thing we need to do is we need to label the namespace that we want to scrape the metrics. So we need to set up two labels, one for the operator that we're scraping, and then one for the operand we're scraping. And we need to add those in the namespaces that we're scraping. So now we get to the fun part. This is the custom metrics that we want to expose. In this part, first we have to declare the collectors as global variables so we can use it everywhere in the reconcile loop. We decided to create an application upgrade counter and then application upgrade failure. So there are 4 types of metrics. There's the counter, the gauge, the histogram, and the summary. We decided to play with counter and gauge. The application upgrade counter is its value can only increases or reset to 1. So it's like a counting code going up, or you can reset it to 0. This one tracks the number of successful operand upgrades processed. The application upgrade failure is a gauge, and it's a number that can go up or down, or you can set the number to be whatever you want. In our case, we're tracking the pod image status. So when the pod status keeps cycling and it never reaches to the complete status, we're looking at the waiting reason as to why. And if we see error image pull or image pull back off, then we set the failure state to 1. To increment the counter, we use the inc method, and we use the Prometheus ClientGo functions. And to set a gauge, we use the set method. So let's look at some live code. I always like to look at code. Okay. So here is our reconciler. Better? Okay. So I'm looking for, so this is our reconcile loop, and what I wanted to show you is we are tracking, sorry, I'm not good at working at this thing here. I want to go to the end. So when I was talking about how do we set the state when we see a status, a pod status that is one we don't want, we can look into the Kubernetes I don't know how you call that, the Kubernetes methods or something, and we can find out the status, and then we use that to increment. I lost my, oh, there you go, okay. We use that to increment. Sorry. Okay, I'm terrible at driving this. Maybe you can drive it for me. Let's see.
I think we should just continue with the demo.
Yeah, we should do that. Okay. And so, well, first I have to flip that thing. There you go. go back to the demo. There you go. Okay. And all our code is in repo, so we can, so you guys can go check it out. The last thing I want to talk about is the Prometheus rule. And when we set up a rule, in this case, we're setting the condition of the metrics, bestie upgrade failure. If that number is equal to 1, then an alert will pop up. So for live view of the, there you go. Okay, so we created a Grafana, and the 52 number here is the counter. So we've created 52 times. And then when we have a failure state, we can set the color to red, and so that's how we're doing it. And I also have a Prometheus. There you go. Can't look. There you go. Okay. Oh, well, we ran out of time. Okay, that was the Prometheus view of an alert. So let me continue this with. Oh. There you go. I also have a demo here because I was afraid that things wasn't going to work. It didn't work, but you can see this in our repo. And so lastly, metric for thoughts. What can we do next? We can also look at maybe the number of visitors from our operand and do something with that. Or we can find out what pages are viewed, and this is all the things that we might look at later. And what operation did the users do? Is it a search? Is it an update? And was it successful or failure? So all these metrics that we can do. And also how many pets were adopted and their labels. And so these are the things that we want to find out before something bad or something crashes. And this concludes the metrics and alerts. And now we'll have Yuri next talk about 5. Thank you.
Hello everyone, my name is Yuri. We work together in our Red Hat Operator Enablement team, and I'm gonna show you the level 5 that is called Autopilot. As Mana just clarified in the first at the first level, basically the level 5 is defined when an operator is capable to do a self-healing, to move the workloads for a better nodes, or to restart their operands, and so on. And then why we are trying to achieve the autopilot. I'm currently a software engineer. My complete background is a SRE in the operations. I worked many times to fix some broken operators. And you deserve a good night. We deserve a good night because the dream works. And we are expecting that our operator is capable to read metrics, and based on the metrics that it consumed or exposed, the operator should also be able to do a outscale. That means the operator should have in place a horizontal pod outscale, and scale up or scale down pods based on the metrics. Move workloads also, because if we have kind of a CPU utilization or a deviation in our metrics, then the operator will move those workloads for another nodes and restart the operands. The operands, Seed and Mana exemplified, we create a web application to clarify the operand. And then There could be a web application, there could be a database, there could be a Prometheus instance. Yeah, and we have many examples that we could create as a operand. Okay, to exemplify our HPA, we decided to create a way to enable this HPA by default. Then, if we gonna create a CR called Bestie, this is basically our operand, and if you set a max replicas field with a value greater than 0, then the operator will understand that we have to create an HPA, okay? Otherwise, the HPA will not be in place. Then we provided to the controller that this logic, if the end user wants to enable or not the HPA by default. Okay. I brought this HPA workflow. I guess, or I think that you already know it, how the HPA works. But just to bring back in the memory, we have our CR. That CR deploys a deployment, and the deployment deploys a replica set, pods, and the pods communicate with the kubelet, and inside the kubelet, if I remember correctly, there is a C advisor, and the metric server actually collects the metrics from the kubelet, and the horizontal pod outscaler reads those metrics from the metric server and acts as we should do. In our case, we're gonna see one example about HPA performing the action based on the CPU utilization metric. Okay, we have a demo. See, I have to slide to the right side, or yeah. Let me. Sorry. Oh, okay. Let me. Here. I can't create operators, but I can slide right along. 3 fingers, yeah. Not this. Not this. This one. Can I have bigger? Sorry? Bigger. Yeah, I'm trying to. Oh, let me try it. Nope. Yeah, nah. Display, nah. Sorry, I can't do bigger, but I'll try to explain. Let me, yeah. Actually, I left the command with get HPA -w, yeah, just to check the current replicas in our operators. And the tab besides, I created a fake load generator, yeah, to simulate a CPU utilization, okay? Basically, yeah, I'm running while true against our endpoint. And then in that first tab on the left side, you're gonna see step by step the HPA spawning new pods. And then actually, I know that it's pretty small, but we currently have 3 replicas. And yeah, when the HPA achieve the threshold is 30% by default, then we're gonna see 5 pods, okay? And yeah, after that we see these 5 pods, I will console the load, the fake load generator, and the HPA will delete this extra 2 pods. Yeah, let's wait. I guess it's wrong, but let's see this. Yeah, 3 turning out the 5. Just to prove that our operator is capable to do the HPA. The difference between that and yeah, a usual operator with the level 1 is we have the HPA in place. And then you don't need to create an extra HPA manifest resource in your cluster. So then if you activate through the max replicas field, be aware the HPA will perform the action based in your metrics. Okay, just to clarify this point. So now we have 5 replicas. Okay, let me just stop it because it's pretty small. And this, what is it? Here, no. Let me go back to the presentation. Yeah. So I brought this kind of warning at the first bullet regarding the API version. I don't know if you are aware of the version 2 of the outscaling. In this version 2, the outscaling is capable to read custom metrics. Okay. Before it, the outscaling could read only CPU utilization and memory utilization. Okay. At the second bullet, I brought a question regarding new ideas because, we are talking about operators, and the operators have operands. And in our case of a web application, I brought 3 options: request per second, HTTP error rate, and number of restarts. But you can think about your application and design the metrics as Rose explained to us today. Okay, and the takeaways of our talk is basically doing a wrap-up of the 5 levels. The level 1 ensure that the operator is able to deploy the operand application. Yuri, but it's quite clear. The operator should be able to do it, but you have to be aware the operator has operand, and the operator should be able to install it automatically. You don't have to do anything to perform this installation. The operator should be able to do it. The second topic, the operator should be able also to perform seamless upgrade, because sometimes the operator can be able to upgrade the operator, but not the operand. And to achieve this level 2, the operator is able to upgrade both operator and the operand. I guess it's quite clear, and the backup and restore are in place. When we are talking about stateful applications, this is really important because once we have some issues in our operands, then the operator is quite important. This is a quite important task to do a backup once we get this issue and restore in another, spawn in another pod and so on. The fourth, I just talked about custom metrics. The operator as well as the operands expose metrics. So then we have the controller, the manager of the operator, and we have the operands. Both are able to expose metrics. I brought Prometheus because, it's a well-known tool, but you can use everything that you want regarding the to expose those metrics. And in the end, the operator is able to outscale based on the application loop. This is the baseline to achieve the level 5 doing an outscale process, okay? But as we can see, for the near future, we are proposing, we are working in our team to, when we start creating a new operator, we have to scaffold the project. And the first challenge that we have in front of us is scaffold a L5 operator with all capabilities in place. Because it will be amazing if you are using operator SDK when you start the project, then you have all the capabilities in place. It's quite a dream. And the second bullet, the operator will take action in autopilot mode based on what it learned from performance baseline. We are talking about here artificial intelligence, because the operator will learn based on a, data lake, And then based on this performance baseline, okay, I don't need to do a HPA anymore, or sorry, not outscale my pods or scale down my pods. I have to spawn 5 pods by default for the next CR, because this is our baseline. Okay? Then is, if you are interested to contribute with the project, I encourage you to help us in this L5 operator demo GitHub, and I have a big thank you for you. Yeah.
All right, thank you very much. Do we have questions?
Come on, guys.
I have to ask this question. When not to use operators?
Wow. Do you want to take it, Sid, or? No.
Oh,
Come
when
on.
not to use operators? That's a good question.
Stand up.
Like, I would say there are sort of, okay, so like all of this is well and good, right? We have all this automation, all this one-click install stuff happening, but there's obviously a cost to it, right? There's like extra development overhead. If you want to do this, you have to spend, extra effort to do it. We're trying to make it, as simple and smooth as possible, but a lot of people, like if you look at the sort of operator hub today, most of the operators are level 1 to level 2. And the reason for that is most people already use Helm to provision their applications. And they would just package the Helm charts as an operator and publish that. And that would be, they get the sort of benefit of being in the App Store, and they don't have to put any effort into it. There's no Go code required. The Helm charts just go in and do the sort of, give them a lot of benefit. So the time when you would use operators is when you want to kind of level that up, right? So you see the traction for your application because a lot of people are using it or trying it out in the App Store, and you want to kind of enhance the capability level. Those people, those kind of vendors or developers or people who are publishing those operators, they put more effort into that. They would transfer from a basic Helm-based operator to a Golang-based operator. They have more data on what's the use case that's relevant, and then they put more effort into sort of automating the relevant parts depending on what their application or their field is. Hope that kind of covers your question. Not really? Not really. Yeah. Any follow-up questions to clarify?
Yeah.
Yeah, hi. If I understood that correctly, to reach level 5, there's a hard dependency on Prometheus?
It's not a hard dependency. Yeah. It's just that Prometheus is one of the it's like one of the defaults that people use. Okay. So you could use Prometheus, but you don't need to use Prometheus. You could have everything done in Go code. You can produce metrics, you can store the metrics, you can manipulate the metrics, you can do everything in Go. You don't need to use Prometheus.
You have to use these metrics and provide to the operator be able to take action based on them.
Okay, so just the logic behind is the kind of gap you have to reach level 5 then?
So the way that the operator framework defines the capabilities, it's like a sort of aspirational or ideal scenario, right? And you would choose the capabilities that are relevant to your application. So what we wanted to showcase is sort of a minimal sort of MVP example of what an L5 operator can be, and making use of as many sort of existing technologies to make it happen. That was kind of our goal.
Because imagine if you are SRE and you have a stateful application in place, and you want to, you can deploy the operand and the operator, but you have to create some other tools or other ways to manage your life cycle, the application life cycle. And then if you have an L5 operator, you don't need to be concerned with anything, because the operator will be able to self-healing, will be able to create, upgrade, and do all the, or I would say not between our code, but all the important tasks to manage this stateful application.
Do you have any sense for like the ratio of adoption of using operators on OpenShift as compared to like all the other Kubernetes types? Because like Operator Hub makes it so easy to discover and install stuff. I'm wondering if like are operators more often used on OpenShift clusters versus other types, or do you have any idea? I don't know how you would know. I'm just curious if you have a sense for it.
Yeah, you mean regarding the ability to install the operators through the Operator Hub in OpenShift?
No, I guess I just mean like in general, like, on, whatever AWS's EKS or whatever, like, what percentage of, are operators being used there, like installed and used there as much as on OpenShift, or do we not know? I'm just wondering, because OpenShift makes it super easy, right, to find them, install them. I'm wondering if that plays a big part in adoption.
I think it does, because in sort of vanilla Kubernetes, you could have the same experience. It's just that you don't get it out of the box, right? You have to install OLM to have this capability of having dependencies pulled in, et cetera, et cetera. OpenShift has a nice GUI for you, and you can go and click it, kind of thing. So in that sense, you might see more traction on OpenShift. That's my sort of impression, but I don't have the actual data to back it up.
Yeah. OpenShift will take care, about some not difficulties, because if you are familiar with the command line, then you can just do manage the installation, for example, using OLM. But OpenShift will basically create a plan, and then for this plan you can install your operator in some specific namespace with some specific version, because the OpenShift will provide you, 3 or 4 different versions that are published in the GitHub repo, basically that, or in the catalog source, right? Or
So for the level 4, for the Prometheus metrics, do you have like some definition on like what makes the metrics like helpful and useful? Because it's like you can't just create like some metrics and call it a day. They have to be useful as well. Do you have like some definition for that, and like how the minimum needed?
So there's the convention, right? I guess the SRE people can speak to this better. But there's the the requests per second, the error rate, and the time or the latency for each request. Those are sort of 3 sort of health indicators that kind of apply to most applications. That's what, in our example, that's what we expose in our operand or in an application. The metrics that we expose in our operator, they're sort of more internal. So they're more for the people who are publishing the operator, like they want to see how their operator is being used. So those are the 2 kind of default sort of things that you get when you, at least in our example, when we created L4. But what metrics are relevant, it would be very much dependent on the application.
On the application, and the metrics are relevant for the next level, because it's quite a dependency between the level 4 and the level 5, because you are exposing metrics and you are reading metrics, and those metrics will be used in the autopilot. In the autopilot, you should perform in your autopilot. You should, create new pods, or just restart. This pod, this basically will, perform some action that you have when you are restarting a pod. You have to do a backup and restore process to ensure that your status is safe. Then this is the relevant topic from metrics, in my point of view.
Yeah, so for example, in our talk here, if we encounter a bad upgrade, immediately we should be able to roll back and also maybe send email or something to say that, hey, your upgrade didn't work, check your pod, check your images and stuff like that.
The idea is to kind of have metrics that give you insight for your application and be able to take action based on those insights. So it's very application dependent. Like there's no answer as such.
Okay, thank you.
Any more questions?
So I said basically why your answer is like the status quo of the use of operators is not when I shouldn't use the operator. And I have many questions regarding the status quo. For example, it's monolithic. It's not following the Unix tiny bits. For example, VMware have Carvel, which they are trying to solve some of the problems of configuration and deployment and whatever, but they are making them tiny so you can make any assumption. Now, in the case of operator, you are making all the assumptions like what we hear, the insights and the metrics and stuff like this.
Yes, it is an opinionated sort of.
And when you mentioned, for example, in level 3, that you might be facing a decision, should I make green-blue update or should I make inline update? Okay, so how can you provide these choices to your user?
I would say
if it's monolithic, and if it's monolithic and you already made the assumption, I think it's hard for the users to make the configuration.
It's something that you would provide in your custom resource, right? So you would have to design your quote-unquote API that would allow you to express, or the user to express whatever they need. So you could have a field that says, enable blue-green updates, for example.
Yes.
And that would happen. And like sort of to bring it to level 5, you can sort of, in an ideal scenario, depending on the metrics that you're reading and the insights that you've gained over some period of time, you can choose your deployment strategy.
In your customer resource, to create a new customer resource, you have to define a CRD, a customer resource definition. And it's like what we decided to create when we put in place the max replicas. Because you have two options. The first option, in example of HPA, you can just create the HPA without informing anything to the end user. Okay, then once your operator is installed, then you're gonna see a HPA in your cluster. But we decided as a team, okay, but if the end user don't want to create this HPA, I don't know, for some reason, because your application don't need a outscaler, or this is not in your project, then you have to basically set the max replicas as 0. And then you not see the HPA in place. And then, as Sid mentioned, it's more related to the application design. You have a monolithical, you have some applications that require some fields, that require some logic that you have to put in place. And your question, when we don't need to use operators, I would say in a stateless application, that you don't need to care about your state. It's basically that, because if you have a stateless application, if you have a stateless application, but this stateless application depends on a database that is running the same, in the same area, or in the same deployment, then I would say you have a stateful application, because you have to ensure your state. But if you have just a stateless, containers are ephemeral. And then you have to basically restart the container, spawn a new pod, delete the pod, spawn a new one, and done. You don't need an operator for it. But once you have a MySQL or a Postgres or something else that you have to ensure the data, then you have to use an operator.
Yeah, if Kubernetes is doing it for you, there's no
Yeah.
need for extra management or logic that would you implement in an operator. No. It's totally, there's definitely a cost to it. And it should be.
Okay.
Sorry.
Thank you very much. We now
Going
have a
over
small
time.
break, and see you for the next talk.
Thank you.
Still you know you have to think wise. No make the computer think, control your mind when you're surfing online, trying to stay over time. Sometimes you need to disconnect yourself and all your mates, and no make computer think, control your weight. Disconnect yourself from time to time. Staring at that screen will make you blind, yo. Disconnect yourself, I will a vibe. No make computer think control your life, yo. Disconnect yourself, free up your weapons. My people watch 11, not run no computer geek, computer freak. Sit down every day in your computer seat. Just a stare up on the screen, nowadays you hardly go a street. You're turning to a geek and you can't see it. Cause if you make computer think for you too much, with reality you know you start to lose touch. People they must say from where they are moving weight. Or you just lock down in your yard and go on computer beer this time to disconnect yourself and well I met. Do not make computer think control your head. Disconnect yourself and well a vibe. Don't make computer think control your life. Disconnect yourself from time to time. Staring at the screen will make you blind. Disconnect yourself, free up your heavens. Idle and shall work for the devil, yo. Watch how you serve, watch where you are stream. Mind how you're turning to a computer fiend. Your daily routine is to stare at the screen. Every day, same way you plug in. So let us forward to basics, unplug from the matrix. Let's face it, our intelligence can't replace it. Our mind is a terrible thing to waste. Even though computer think it around the place, I'm on a say. Disconnect yourself, and all I'm no make computer think
sys11. All right. Okay, welcome back. We have our last talk before lunch. And Sasha Siegel from sys11 is going to talk to us about how we can manage third-party software in our GitOps setups. Yeah.
Thanks.
Welcome, Sasha.
Thanks for joining me. Thanks for having me here. I'm Sasha. I'm a pre-sales consultant at sys11, and I'm usually the first one kicking it off with the customers, talking about their IT landscapes, what kind of software they're going to use, and especially how they want to utilize it in the Kubernetes environments. I held a talk last year about the concept of GitOps, and another one where I've been talking about all the tool chains the people are using, and there were a lot. So the last talk that was missing was how to utilize everything I've learned last year, put it together, and give it back to the customers, or every engineer. And that's what we're going to do today. I've created a 40-minute talk. I'm going to do it in 25 minutes. So sit tight. I'm going to talk briefly about GitOps as a paradigm. We're going to go briefly through a simple example. Then we're going to have a look at how it actually derives into a multiple software development lifecycle tool or approach. And then I'm going to present to you how we at sys11 actually want to do this for every engineering team that exists. And in the end, we're going to talk about the learnings and the findings we had there. I want you to remember after the talk 3 things. The first one is always look out for your software supply chain management. This is a really important matter. Try to actually collaborate with everyone who's involved in your software setup. So even the operations teams who do not code on your software. And the last one is always stay declarative. Imperative is something you can actually abstract, but make it declarative in the end. So let's start. During the software development lifecycle, it already tries to utilize the DevOps philosophy itself, but the approach was always a bit unclear. GitOps made it clear. As they said, we're going to create one fixed point, so there must be Git setups. And that's all you have to do, and now you can start coding and doing your software development lifecycle. There are 3 core concepts to go. The first one is everything should be handled as code, everything declaratively. And if you want to actually communicate with other engineering teams or with systems, make it via merge requests, pull requests, issues, and so on, so you can document the actual problem. And during your software development lifecycle, always remember to utilize your CI/CD tooling you have, so you can create a workflow as a chain, as a pipeline, and get it back onto your production setup, for example. Let's have a small look into the concept. So we're having a software engineering team who's actually creating the code. They have a separate Git, either be WordPress, Prometheus, MySQL, or any other things. They're going to push it to Git, and as soon as it's merged, it's going to create some resources that can be used by others. In that specific case, it's going to be a container image and some configs to it, Helm charts, values YAMLs, for example, and stuff. And they're going to inform the system engineering team who's actually trying to deploy it. Usually fully automatic, because we want to run into errors, so staging is going to be error-prone. And after that is checked, we're going to deploy it to prod. There's 1 second fixed point coming up. Thanks to Kubernetes, the infrastructure stays the same. This is a huge opportunity to actually standardize pipeline thoughts and workflows. So we're having a platform engineering team who takes care of Kubernetes. They're involved just by having a look into it, having the monitoring maybe up, and just keep everything together in the production setup. So this example only displays one software development lifecycle. If we want to have a look into a production setup, there are a lot of different tools we need to use. If we concentrate just on a Kubernetes cluster itself, There are things like an ingress load or reverse proxy, sorry about that, or even the monitoring. And even for the individual app directly, there needs to be some dependencies to a database management system, maybe for improvement of the loading time. We have a memory caching system and even a message broker system. And if we want to stick to the GitOps principle in theory, we have to do it for every single software. We have to do the software development lifecycle for each and every software in itself. This can be pretty much work for just one team if they actually want to do it. And if we stick to the DevOps principle, you build it, you run it. So the big question here is, how can we actually lessen the effort the team has to bring up to? And there's one classical solution since the 70s. It's always third party. Just bring in some other teams to help you just install it. So far, so good. Because we have Kubernetes, because we're having Git, it shouldn't be any problem to actually install it and have it running. Well, there's a little detail, operations management, we call it day 2 or day 3 operations, the things we cannot see beforehand after the deployment. The classic error during Kubernetes management is, for example, the certificate management. Easy error, everyone has it at least once. So the different communities actually decided to deliver the software with some resources. They cannot see and they can't help you to actually individualize each and every software, so you can actually be happy with the software during the next 2 to 3 years. So we thought about that, getting the software delivery done, getting the CD pipeline chained with multiple steps ahead, and give the customers or the engineering teams itself, like each and every engineering team, one big pipeline. So you're starting on the left with your own software, you're adding some other softwares, you're trying to keep it documented during a Git repository, and you just blow it out into any Kubernetes cluster of your choice. Let's go one layer down. So this means in the end, we're having multiple pipelines we're going to try to combine, and we're trying to generalize them in one specific fixed point, at latest in the merging stage to prod, like in the deployment phase. And this was our goal we actually tried to achieve. We wanted to create an automated workflow everybody can work with. It doesn't matter if you're a software developer for WordPress or if you're an infrastructure or platform engineer for OpenStack and stuff. Everybody has to be generalized, so everybody can work with it and everybody helps each other out. So we wanted to improve collaboration. This was one specific task we had. We wanted to stick to GitOps based on Git. And we also wanted to automate as much as possible by not losing any customization everybody has to do. And that's what I'm going to show you now. So merging every software you need starts always with a Git. We're talking now about the continuous integration for every software. We're going to start with GitLab in our case, and the CI tool GitLab CI itself. We expect every software vendor or any engineering team to deliver us either a Docker image or container image itself and some configuration items for the deployment, Helm. After that, we're just making sure that every delivered part is actually correct, that there are no deprecation tasks, which we're going to check with Pluto, that the config templates can be created out of those given resources and documentaries or documentations. And we're also going to do some tests we had experienced before. So this is what we're going to try to achieve before we're actually delivering every software. In this case, we're going to have multiple stages. And because we're working on GitOps, nearly each and every stage has its own Git repository. The aim is that the software tools on the right are going to be enriched with some best practices from us, and it's all tested, and everybody can just leave these steps behind and just use the software as is. So let's start with the pre-stage. The pre-stage was the most interesting one because we actually thought about generalizing everything and what can be shared by each software. And we were finding some different checks and scripts that can be used for any software regarding every style, every standard we could actually utilize. So semantic versioning, policy testing is actually an infrastructure thing which we deploy to the software, where we actually want the software to behave the way we want, some kind of corporate policy if you want, and also some scripts for data collection during the CI pipeline work. That's why we created the so-called shared resources repository. As you can see, there are multiple scripts. There's a subfolder policy, so Python or Go. All those can be shared by every software because this is the preparation up front. The tool we used here the most is not actually a tool, it's a programming language. It's Python, because everybody speaks Python. We can actually say that there are a lot of different libraries that can be reused that we just have to manage in its dependency management. And for example, here we're actually checking two different values YAMLs from the Helm chart with the library deepdiff, which is already maintained by another community. So we can actually enrich that. Everybody can read that, and everybody knows what the steps will do. Next one, the linting stage. So we actually separated the testing stage into two testing stages. And don't be confused, we call it a lint because the first main purpose was linting, and linting is a huge thing during testing. So that's the case here. We're checking still generalized for every software. On the dependencies, we're scanning for different CVEs. We're going to have a look up if the config, the values YAMLs changed a bit. We're going to have a look if the policy changes from the software vendors changed, or even validating the delivered resources in form of a container image and the Helm files. So because this is still generalizable, we created a new repository, the templates repository, which is not readable here, but they are all the default jobs you can imagine of that I just listed up on the page before. And one big tool which helped us out here a lot, which I want to recommend, is a plug-in to the Open Policy Agent. As we start with the pipeline, we expected every customer to at least work with Open Policy Agent in a way of they're gonna deploy that someday. So Open Policy Agent has a separate tool called ConfTest, which gives us the possibility to write policies and test them against an Open Policy Agent without actually having the deployment of an Open Policy Agent. I'm going to skip the build part because we all know how it's done, Docker build, and that's it. So we're going to go straight to testing. And this is the actual breaking point. We're having now reached a point where the generalized approach reached its limit. We're having different test cases for each third-party software, which has to be checked, which has to be delivered maybe from the different engineering teams. And now we're going to split up the general pipeline, and we're going to create multiple Git repositories for each and every software. And they include, next to the scans of the API versions, which has been a bummer in the 1.17 to 1.18 Kubernetes upgrade, for example, also different tests, we call them smoke tests. So the specific cases each and every one has to be checked here. The Repositories are so-called Helm file repositories. The reason is that we're here actually trying to utilize the Helm file tool, including to the Helm chart tool. And here also, this is not readable, I'm going to change it for the next talk. Different directories where the smoke tests reside. So because of the specific smoke tests we have, like for Prometheus, we have to check if the metrics are actually readable. That doesn't occur on any MySQL server. There we have to check maybe for the different database tables or something. They're all that specific, and that's why they reside inside the Helm file repository. So if an engineer tries to find anything specific about the software, they're looking into the Helm file repository and see it at a glance. So why Helm file? Helm file is actually our most basic approach, and everybody, or like most of our customers, have some experience with Helm file because of Helm chart, because of the de facto standard it's trying to reach. So that's why we're working with that. We're trying to give the customers some combined Helm charts, especially for multi-tier applications. If you're thinking about a MySQL database, which actually includes a HA proxy for this scalability and stuff. All this can be done in an easy step with Helm file, and customers or other engineering teams. I'm saying that I'm just defining customer for a second. So the customers actually any engineering team who wants to use the software, not like the Sys11 customer or the internal teams like the platform engineering team, the actual software engineering team for the front end or something. So. Besides that, everybody can patch or add missing features into their Helm charts by using Go templates we provide them with, and they can actually just add further stuff more and more. I've been talking about the smoke tests before. This is an example for the Prometheus smoke test, where I've said that we're actually tracking the same metrics by start, and have a look at the replica stuff. After all that is done, we actually secured the software supply chain management, and we can now re-release all the work. To be more specific, we're just giving over the Helm files and the Docker images provided by the vendor. But also we giving a pre-populated Helm file values YAML. So the best practice configs we experience or other engineering teams experienced are actually residing in there. We're also giving for the software delivery, for the software deployment later on, different CI templates, and if there are any breaking changes or even bugs in the software, we're trying to offer some workarounds or even work with the engineering teams to find a workaround so everybody can use it. In the end, after all this is done, also the things we want to deliver, we're creating automated some release notes so everybody can rely on that. We're actually creating merge requests with those different informations, and on the release notes we're showing the customers to the different merge requests so they know specifically what has changed and why there is a breaking change. One last thing I want to mention is during the release we actually integrated Renovate, and Renovate is a really cool tool for automated releases. So we started with 12 different software tools and had about 100 updates per week for those 12 just in January. They probably got a bit bigger by now, but that's how we started off, and it keeps track of every change, so we don't have to do this manually anymore. I've talked about 2 fixed points in GitOps. So we're having the Kubernetes cluster as a standard. We're having the Git or Git as a repository or as a method as a fixed point. And because there is like a jump between the actual runtime and the software development, we had to make sure that this somehow fits for the later stages. So we had to create another fixed point, We have a custom resource definition created, mainly because we wanted to enable customers to integrate the software into a monitoring tool, and we decided to go with Prometheus. And the customers do not have to install the Prometheus cluster, but if they do so, everything is already populated to go up front there. So, as I said, the continuous integration is finished. We're talking now about the continuous delivery or the continuous deployment, depending on who you ask. So just to remember, we wanted those steps done before the deployment and offer those services with the different resources already delivered, plus best practice configs. And this is how it actually looks like. We have one GitLab CI YAML, which actually includes local GitLab CI YAMLs in every subdirectory. And inside those subdirectories, everybody can define the values he needs. Stuff like the domains for the Ingress controller, or the passwords and the usernames for the database or stuff. This is what resides in the subdirectories, and there's nothing more to it. This is how our engineering teams can actually now deploy really new application stacks in a really fast manner. If you want to define the services, we actually made them aware of the different environments you can use. So usually there are three environments: the development, staging, and production environment. And this is what you can actually define for each and every software. And because of the Helm file feature of the Go, with the Go templating, you can actually create so-called values extensions and add to the values which already exist. So, third-party software is a thing to go. It just eases your pain when the boss comes around and wants to deploy the new applications that you've been working on for a week. And we just try to enrich all the third-party software offers by giving out those centralized GitLab CI pipeline or the CI/CD pipelining itself. And if you have a look at all the stages we have here, you just have to define two. So there are two stages in the deployments we recommend: the diff and deploy. The diff actually just checks your Kubernetes cluster, and if it's upgradable, and if it's so, it's actually doing the deployments. Let's get to the benefits and limits. So before we get to the benefits and limits, the first benefit is, if it's still GitOps, it's a good thing. And we can actually say that that we stayed on the path. So we're having everything is code, everything is declarative. We use Git as a mutual source. The merge requests are giving us the transparency we need. We have in the continuous integration and delivery set out for everybody so they can use it. And if they want to enrich it with other tools, they can do so. If we look at the software development lifecycle, maybe you've already understood that there are two steps we missed out on the whole chain we've created: the monitoring and the operating. So there are two good reasons for it. Monitoring is a reactive thing. You can never say that you can actually get every upcoming error with the alerting. So you always have to react to it. That's why this will be a manual step. And the second one is the operating. And this is a really simple thing. Besides the reactive process we're having, there's a so-called shifting left testing. And the shifting left testing enables us to actually put any operational task which can be automated up to the left side, even as far as to the actual software vendor. If there's a specific use case they can handle inside their software, they're going to get an issue, either from us, either from you as an engineering team, as a user, or even from the platform engineering team if they see that in their logging. And this is what I want to stress to you. The shifting left testing is enabling us as a software engineering team, each and every one, to commit to other communities in a DevOps style and way. First, the bad thing, so the limits. We've been trying heavily to standardize everything we're having. So this also means that we're having a lot of refining and refactoring as a manual and daily task, which actually takes a lot of effort in the end, the more we standardize. Operations management can still only be partially automated, as mentioned before, during the alerting and the operating. There are things we cannot catch. And just because we collaborate with each other or have a cooperation between two teams doesn't mean the actual workload gets lower. The limit here is that it binds stuff on both sides with less time in total, but it's still there. And everybody probably experienced it, making up a pull request to a open source community on GitHub doesn't mean it's going to be fixed. So it has to be generalized enough. So everybody has to take its profit out of that. And if the benefit is not big enough, you're running with a special use case you have to adopt by yourself. The good thing, though, is we made the multiple services deployment easily integratable for everyone. Everybody can look up the steps. It's transparent in its own way. And if they want to enrich the workflow with some use cases or tests, or even on the linting stages, they can do so. If they're not able to, or if they don't have the time for it, they can actually open issues specifically to the different steps. And the scalability for new services is there. So adding new services just gives us the possibility to put it in there. I forgot what I wanted to say in the ending. Anyways, that was my part about the third software management. If you want to see that software in action or this workflow, we're going to be on the KubeCon. I've got some free time there. I'm going to give you some showcases to it. So come around and join us. Thank you very much.
Any questions?
So hello, have a nice talk. I have a question. So how do you, so for example, if I am one of your team members, so one team or client, as you said, and I want to have create a new service, and I don't want to use this, and I want to go to production, how do you force that this is compulsory? How you force that these steps needs to be set in your pipeline, or which ones are the minimum?
Yeah, good question. We're actually enforcing it in an abstraction layer. So I've been talking, we're having the continuous integration part, and we're having the deployment part, and we're always recommending to start with the deployment part. So it's abstracted in the first part, because in our experience, everybody wants to start with it, even without any knowledge, and they just want to get ahead in a quicker time. So they're going to start on it, and then they're trying to get used to the deployments itself, and if they have any individual demands, they're going to step by step go through the process, and we're trying to get along. But still, if they have any individual use cases, they have to put it somewhere else, and then we can screen them. That's the possibility. Yeah.
And another thing that I want to ask, you were talking about OPA. Did you enforce the OPA also in the production clusters? For example, you have your test, and then you, I don't know, you forced to have to fulfill these OPA rules in the production or staging cluster, or if you are doing it in the staging cluster, or all in the production cluster. This is also my question, because we are facing this, and we start putting it on our test cluster, but we are not sure if this is the best way to do it at the moment.
Good question. So the Kubernetes clusters, our product is MetaKube, which is just a vanilla Kubernetes in itself, kind of. Those are run by our customers. That means they decide what they want to do. Okay. But we're always like, that's one of my job, to go to the customer and say, we tested it, the configuration is simple, just put up the open policy agents, and you have at least the standard policies.
Okay, cool, thank you.
Hi, Sasha. Hi. Great talk. There is an option, for example, in the CI test stage, to create something like a mitigation of potential risks. Something like, imagine that the software engineer or the SRE submit a pull request to create a diamond set in a 1,000 node cluster, and then you're gonna have more 1,000 pods.
Mm-hmm.
I don't know if you break your cluster, but you're gonna have more 1,000 pods load. There is an option to mitigate this potential risk. I mean, in the CI stage.
No, because we don't want to. Because this is like you build it, you run it principle. I want you to actually be aware of what you're deploying, and we're just trying to help you out by abstracting it with a deployment layer. But as I said before, we're trying to get you deep into the software you want to use, which also means during the production, you have to be aware of 1,000 pods which are coming up.
Okay, thank you.
And usually, one thing though, the infrastructure should actually handle that and not the CI pipeline in the end. So if you're running out of pods or it's getting too big, this is something cost maybe.
Sure, but I mean before the diamond set get in place.
Okay. Yeah. No.
You know,
okay.
it's kind of okay.
Yeah. Then when you're on
Are
the
you
first
sure that
answer.
you want to create 1,000 pods? You know, something like that.
This button is missing. Yes.
Yeah.
All right. Okay, last question.
Thank you for your talk. I was wondering if who has access for the production cluster? If I mean, if for example I'm an engineer and I'm going to change any resource in the Kubernetes cluster in production, how you can reconcile with your infra with GitLab CI?
So you mean you've been developing with the tools and now you want to deploy to the production
No,
cluster?
I mean, if I change any resource in production or in staying clusters by hand, how you can reconcile with the stack that you are deploying?
Well, you don't. Like the help charts are actually always looking up the different resources. That's why we rely on that. If you're making actual changes on the software on the Kubernetes cluster, it tries to roll back those changes. Every change that is allowed is actually out of the Git repository itself. This is what we actually want to. We don't enforce that; the tools enforce it. But yeah, that's what we're actually relying on.
And how you manage the secrets for this?
The changes?
The secrets.
The secrets?
Yes.
This is. It depends on the deployment of yourself. So if you want to use a vault, then you can use a vault. If you want to do it with a GitLab CI integration.
I think he's talking about, imagine that your developer or your client writes some secrets that they shouldn't write in their deployment, in the values, for example. Do you check that with some CI step or something like that?
Secrets are like, we assume that there are passwords inside the secrets that actually belong to you and not us. So we don't check those.
So it could be that the secrets are in the repository.
In the deployment repository,
Yeah.
but not inside the continuous integration repository. Exactly.
Okay.
You build it, you run it.
Okay.
Remember?
Good. That's right. Thank you.
Thank you very much. We now have a lunch break until 3. Enjoy your lunch and see you there.
Yeah, love but never forgotten. No.
Old make it, yeah, yeah. African head, yeah, yeah. Carve out a stone 6 ton this mallet. 40 ton is the biggest. Old make it, yeah, yeah. African head, yeah, yeah. Carve out a stone 6 ton this mallet. 40 ton is the biggest. You will return to Tolan in the year Se'at to avenge betrayal. Quetzalcoatl, yeah. Quetzalcoatl, Quetzalcoatl, yeah. Quetzalcoatl, Quetzalcoatl, young prince, you come from Tolan, oh yeah. Rule over Tolan. Topilits in an actual person. No human sacrifice when you were around. Enlightened emperor with a turquoise crown. Flourish the Toltec civilization. Prayer and penance is your foundation. So strong. Your heart, them assist the obsidian one. Trick and shame you, fast you to run. Never to return, but we know they were wrong. Yes, they were wrong. Quetzalcoatl, yeah. Quetzalcoatl, Quetzalcoatl, yeah. Quetzalcoatl, young
Test, test. Wonderful.
from Tolan, oh yeah.
Okay, so our next speaker is Michael, and he is going to talk about how to debug containers in Kubernetes using sidecars. Welcome, thank you.
Hi, welcome back, and thanks for being with me and for your interest. I'm now going to talk about how you can debug a application container running behind a sidecar in Kubernetes using Gfira. So first things first, I'm Michael. I'm a software engineer and co-founder at Blueshoe. In my day-to-day business, I'm usually approaching Kubernetes from a developer's perspective. And yeah, if you want to reach me, then drop me a line at michael@unicube.io or find me on GitHub. So a quick glance on the agenda. First, I'd like to introduce you to the project itself, Jifira. I prepared a little demo application as it's an OpenID Connect login flow with a backend and obviously a sidecar running the OpenID Connect things. Then I will look into what's inside. There's a bug hidden in the code, which I want to debug using VS Code. And in the end, I'd like to wrap everything up. So first, I'd like to know who of you considers herself or himself a software developer? Cool. And how many of you are writing excellent code? Wonderful, that's the spirit. Well, my team and I started Jifira in order to create a completely new way of making or having developers writing code with using Kubernetes right from the beginning. And then afterwards testing and yeah, basically everything around working with Kubernetes and making this as convenient as possible, as convenient as a Docker Compose app, for instance. And how many of you have heard of Telepresence 2 or even use it? Okay, so I'm not bashing it too much. Well, why do we actually want to work with Kubernetes right from the beginning? Basically, what we're trying to do is promote really a service-oriented architecture to be applied to all kinds of modern applications. And what we'd like to see more often is that advanced Kubernetes patterns are becoming part of software architectures. And one of my favorite is the sidecar pattern for a number of use cases. Why Kubernetes right from the beginning? So this is obviously a point coming from the 12 Factors app. It says, I think it's factor 11 or so, that we'd like to have a real high dev prod parity, which means if you're running your workloads on Kubernetes in production, it's probably a good idea to do this during the development as well. And we found that current solutions, for instance, Telepresence 2, did not really match all of our requirements. So in speaking about Telepresence, you cannot easily connect to a cluster and debug an application that runs behind a sidecar, because what Telepresence 2 does is it puts another traffic agent into your pod deployment, basically, which then intercepts traffics, and you are not able at this point to pass your traffic to some kind of a sidecar pattern here. Another thing is that Telepresence 2 modifies your workloads in the development clusters, or even if you're brave enough to do this in production. And if there goes something wrong, so basically anything, the workloads are then still modified in the cluster, and you will find a hard time to get rid of all the components. And these are things that we have been dissatisfied using Telepresence for almost 2 years, and so we decided to come up with our own solution, which is Jifira. Another thing that Jifira is basically built around is that we'd like to provide all kinds of development toolings that developers are using nowadays already. Like, for instance, you can use your favorite IDE, whether it's VS Code or PyCharm or Vim or Emacs or something like this, for languages that support code hot reloading. We want to support this. Of course, you want to mount your current working tree, speaking about the source or other dependencies, as volumes into your current development container instance, override environment variables, drop into in shell, and do all these things, right? And Jifira achieves this by spinning up a local container instance of your application on a dedicated Docker network. And with a component called Cargo, in this case, it creates a WireGuard VPN connection to your Kubernetes cluster. It is completely automated. And using this connection and patching the network level of your container instance here, the application container will behave as it would run directly within Kubernetes, especially when it comes to networking and everything around that. So here's my example application. Hopefully this will work well. I have a local K3D cluster running on my machine. So I have to put up the cluster configuration, port forwardings, mappings, the correct Kubernetes version. I have to do a little bit of Helm charts. I have to do a little fiddle around with customize, apply a few YAML files as well, and work with kubectl, obviously. And what I get once I applied everything, I will have a Kubernetes cluster, as I said, based on K3D. I am going to install a Keycloak. It's an identity provider with a custom realm and my demo application as a client already installed. I will have a test user with the required privileges in order to perform the OpenID Connect login flow. I need some sort of ingress config that supports this flow. And obviously, I need a workload with my demo application, which implements the sidecar pattern. And in this case, I will be using the famous Fast API framework, which is Python-based. So, and in order to have this up as quick as possible, I will be using another tool that is coming from my team. It's called getdeck. And all I have to do is run deck get on this repositories. It's the Jafira demos. And the name of this demo application is called auth2demo. And if my internet connection is not too poor, this will spin up the cluster and apply all the resources. Maybe we'll have a little detour at this point. I'll look into the deck file. So we have heard like dev file today already. This is a more simple alternative, I think, which is less complex, but also less powerful. You can specify a cluster provider, so we want to provide K3D or Kind and Minikube in the future, and put a native configuration here. And then there are DEX. The DEX is a new concept coming with getdeck. It's described as a unit, or the simple, smallest installable unit coming with getdeck. And there's this auth2 demo. So we are using code-centric Helm charts here for Keycloak. Have a little configuration, then initialize this Keycloak instance locally, and apply the workload for the old demo application. And then there's a Kubernetes dashboard here just for our developers. Wonderful, and getdeck does exactly that. It spins up the cluster, applies all the sources, and yeah. Yes, now I'm ready to work with this cluster. But first of all, I'd like to get back to the presentation, so what's inside. With these workloads, I installed on the right-hand side everything what is needed for Keycloak, with an ingress running on Keycloak on my local domain, with a service and a pod running the Keycloak instance. And on the left-hand side, there is my demo application coming with a dedicated domain on my local machine with a service. And here we are running a pod coming with the auth2 proxy. So this is a third-party dependency in my application. It's installed as a sidecar, and it works like this. The traffic comes through my ingress configuration and hits the auth2 proxy. The auth2 proxy is then handling everything around authorization. And once the request is authorized, it gets upstreamed to my actual backend application. So just a quick recall what OpenID, what the OpenID Connect flow is looking like. So if I want to hit my backend application, it's not readable very well here. So it's over there, and I hit the associated domain with my browser. I first hit the auth2 reverse proxy, which redirects me to the identity provider. Passing my credentials to the identity provider will return an authorization code and a redirect to my backend application to the auth2 reverse proxy, which then redeems the authorization code and in exchange receives the actual access token, which is then passed in a header field to my backend application. Just a quick view how a sidecar is implemented. Maybe a few already used this in applications too already. So this is the container section in my deployment manifest. And it says in the first line, there is this OAuth2 proxy, which is a standard component here, running on container port 8809, which is my port being served by the Kubernetes service. And I have a configuration in this OAuth2 proxy config map, which is referenced in the end from, which states that I want to upstream to my OAuth2 demo app container, which is the second one here, which runs on the internal container port 8155. So this is basically everything that is needed to prevent unauthorized requests from hitting my application in this case. Wonderful. Let's see this in action. Get back to my shell. It says, please find the app at OAuth2 demo on this port with username gfira, john@gfira.dev. So I will call this. And this is the landing page of the OAuth2 proxy. And it says, OK, sign in with OpenID Connect. I hit that button. And please notice how we get redirected to Keycloak. So this is a full-fledged OpenID Connect login flow on my local machine here, which is quite convenient for all kinds of development works, either for backend, but most of our front-end developers like to work with access tokens in order to leverage them in their front ends as well. So I'm just copying that. It's for a username and also goes for the password. Sign in. Wonderful. I'm seeing the output of my Fast API application backend, and it says hello world. And if I remember correctly, I can go to the items 1, 2, 3 route, and oh, okay. This is a 500, so I'm seeing a bug here, and that's pretty much what I want to talk about with you next. Here you can see the code that is serving the items route. And I think the first thing that comes to mind is a not too uncommon pattern. If there is an if-else branch, and in the if branch, it checks if we are seeing an forwarded access token. And if not, so this is the else case, this might go into a Docker Compose setup, which does not leverage the OpenID Connect and the OAuth2 proxy as a sidecar, and it simply does not extract the email address given in the token. So patterns like this are really anti-patterns, and we don't want to see this in the future and not in our code, obviously. And this is like to show you why we are really promoting this development approach. And as an attentive audience, you might already spotted a mistake in this snippet, but I want to keep this open for quite some time. So here is what, when gfira comes into play, so it's quite simple. You run a gfira app, which sets up gfira with the connected Kubernetes cluster. And then there are actually two scenarios how you can use gfira. So the first is gfira run, which will create a local container instance running on your local machine. And you will be able to, for example, add a new service to the cluster, which is not being reflected in the workloads already. So you can create a completely new service and make it part of your service mesh. And then there is this gfira bridge command, which effectively intercepts a container that is running in a pod in the cluster and tunnels the traffic that goes into that container down to your local container instance, which will effectively make you able to write code and see your changes immediately reflected in the cluster. And obviously, for this demonstration, you can even attach a debugger to this container instance running on your local machine, and with as many instances as you want. If you, for instance, want to debug two services that communicate with each other, both have really well-documented contract testing, everything is working well, but sometimes there are bugs hidden in between two services communicating with each other in Kubernetes. And this is really useful in order to hunt those bugs down. You can write code And if you're done, you run Gfira down, which will effectively reset the cluster to its original state. If there's something going wrong, Gfira does not modify your workloads, so you could also easily delete the pod that was being intercepted, and it will be spawned back with the original one, right? Okay, so here's the first command. It has quite a parameter list, but I will go through it very quick. So the first is the image. This is basically the one that is also deployed in the manifest running within the cluster already. Since I am spinning up a new container instance, I can also assign a name for further reference, and I want this container to behave as it would run in the Kubernetes namespace OAuth2 demo, which I just created. I am mounting my source code from my local machine here into this container instance, and I am overwriting the startup command. So in this case, I will be using debug.py. This is a Python implementation of the adapter debug protocol, which is available for quite a number of programming languages. I can tell to wait for my debug client to connect, and if the client is connected, then it's after the second -m here, I will be starting UVcorn, which is a Python application server with the main script serving on port 8155. So this is then exactly the same as it is written in the workload manifests, except for the reload flag, which allows me to make changes to my code, and the application server instantly reloads this. Well, heading over to Visual Studio Code, as I said, I can check kubectl, control get an S to see, okay, there's my auth2 namespace, and just to have a quick look at the workloads running in it, it's auth2 demo. Yeah, it's a Kubernetes dashboard and the Keycloak and a Postgres serving as backend for Keycloak. It's a database, and now I'm running Gfira up. And Gfira up, as I said, is now going to install all cluster side components, which is basically an operator that is used in order to create the cluster side infrastructure. And it also installs the WireGuard endpoint within the cluster in order to set up the VPN connection. Yeah, depending on your internet connection, this may take a few seconds. There's an open feature request playing some easy listening music here. Wonderful. So, of course, I created a little note here so I can just paste in. So this is the command that I shown you already. And it started me a local container instance. I can inspect Docker PS, and I see my fast API demo application. This is now running as part of the cluster, but since there is no connection from Kubernetes objects to that particular container, I won't be able to receive any traffic here. I could instead create requests in this container and work like a new service that is not being consumed by any adjacent service in the workloads. But this is just one of the first use cases for Gfira. So now I'm going to attach my debugger. But before I can do this, I need to figure out the local IP address of my container. And it's this one. By the way, this will be a feature of Gfira in an upcoming release to make this a bit more convenient. I go and say start debugging. Okay, why does it start immediately? Arc. Just restart Visual Studio Code. Wonderful. I can say remote attach, and here I can paste, no, not paste, copy here. paste it there on the default port. And as you can see, the application is started already, so my debugger is connected to this application. And now, getting back to my slides, I will create a Jifira bridge in order to replace the container with the bug running inside my cluster with the instance that I just started here. So it's Jifira bridge. On the one end of my bridge, I will have my fast API demo. So this is the container instance that I recently started. And then I want to target all pods of the deployment auth2demo in the namespace auth2demo. And so this will, if you have a replication of 2, 3, or more than one, basically, Jifira will create a bridge for each of those pods. And within every pod, I'd like to target the container auth2demo app. You remember, it's the one behind my sidecar. And then I can do the port forwarding. And I also can assign a name for this bridge, even for further reference if I want to get rid of the bridge afterwards. So I can do this with this command in my terminal. Clear. And it will take a few seconds to come up. What happens here is that Jifira places a special proxy in the container of the pod that is already running and dynamically configures it to have a dedicated target for the traffic. So this is what happens here, and my bridge is established. And now I will be able to get back to my ingress and see the hello world output. And this should be okay. Here's a request log, so I can have a few more requests, and hopefully you can read this. Well, and now I'm trying to inspect my token, and so I can just simply place a breakpoint here and get back to the items route on 1, 2, 3, and my VS Code instantly comes up, halting the execution at my breakpoint, and now I'm able to introspect the access token in order to see what's going on here. And yeah, it's an email with a lowercase actually. So if I hit the play button, of course, I could have read the log output here, but where's the fun in this case? So of course, this is quite simple, but I think all of you know when a debugger comes in handy. So I can just simply make this a lowercase e, hit the save button, the application reloads. Oh, there's still this breakpoint. Just let me mute it. Wonderful, and so I have fixed the bug. My output is now generated correctly, and it extracts the email address coming from the access token. Wonderful. Yeah, basically that's it. I can now commit and push and be very confident about this working in integration and production scenarios as well. So yeah, I fixed the bug. It was a lowercase email here, wrapping everything up. I hope I could have shown you how to create a Kubernetes native development approach with advanced Kubernetes patterns, if a sidecar is sort of an advanced pattern, and making this also available for developers. And your developers, I mean, you probably know this too, do not in every case want to switch the development environment in case of the editors. So everyone is basically like to stick with their favorite IDEs and toolings and stuff. And so Jifira could be useful for you to make this possible in the future. With this workflow, we don't need any more Docker Compose or Vagrants or custom scripts that do not really fit the production system. And if you want to follow along this demo, then you can go to this link. And if you're interested in using GetDeck as well, then have a look. And yeah, that's it. Thank you very much.
So, hello, nice talk. Which permission do you need to have to install or to run Gfira in the cluster? So imagine I'm a developer, I have limited access to the cluster.
Yeah.
Which roles and rollback, all this kind of stuff needs?
Yeah, so this is using WireGuard Go, which runs in a user space, which is kind of different for the usual scenarios of using WireGuard. And this makes it requiring less privileges. I think it's still required to run privileged mode, and currently it requires you to create a new namespace. So everything goes into the Gfira namespace, and I think these are the least required privileges that you as a developer need in the cluster.
So it's a little bit related. You as a developer, you need access to the control plane, but also to the nodes of the cluster, right?
Yes.
Okay.
Yeah.
That was my other question.
Yeah. So if you, for instance, want to use it with the Google Kubernetes engine, there is a firewall setting that you need to define in order to have an open node port, because this is a node port connection, which is very robust on the other side, but requires a little bit of configuration in order to make it possible. You're welcome.
Any more questions?
Thank you for your presentation. So, are you using it mostly in local Kubernetes cluster? I'm curious about like developer workflow. From your experiences, are you using it just against, I don't know, staging or dev cluster, and many developers are just sharing the cluster setup and working with the services that they own, or is it more like decentralized where they have the same setup locally?
Yeah, honestly, we are currently working with local Kubernetes clusters using K3D or Kind or Minikube, because so this is quite a new project, and resource contention, for instance, would be a problem in centralized development clusters. So yeah, we are currently working on getting rid of Docker Compose in the first place, and then see how this evolves in order to also support developer workflows with centralized Kubernetes clusters.
Yeah, makes sense. Thank you.
Hi, thank you for your talk and for the presentation of the tool. I just would like to know if it is actually it can be used actually with Minikube or not for the moment.
So Gfira itself doesn't make any assumption where your Kubernetes workload is running. So it supports Minikube as long as you can make sure that you have the node port connection available to your client, and then it can be basically everything.
Okay, perfect. So basically, you are agnostic regarding if you use Minikube, Kind, and all this sort of stuff, as long as it is a local Kubernetes cluster, right?
Or you can also run a cloud-based Kubernetes cluster as long as you can make sure that you have the node port connection available.
Okay, thank you for your answer.
Okay, thank you very much.
Thank you too.
Okay, I think this is time for our next presentation. This is Christopher. We're talking about how to bring Apache Cassandra closer to Kubernetes. Welcome.
Wonderful. Everybody hear me all right? It's working now. Awesome. Yeah, so I'm Chris Bradford. I'm from DataStax. I'm going to talk about bringing Cassandra closer to Kubernetes. I personally work on an open source project called Cassandra, which is all about running open source Apache Cassandra on Kubernetes. This talk is going to be a little bit different, though. I'm going to be talking about a technology that we built at DataStax to kind of merge the two together a bit more. One is the Cassandra is more about just running Cassandra on Kubernetes. But Cassandra is a number of years old at this point. It predates Kubernetes by, I want to say it was 8 years. And so it has some things that it does internally that maybe we could leverage native resources inside of Kubernetes, and maybe a little bit vice versa. So first things first, I want to do a special thanks to my colleague, Jake Luciani. He's done a version of this talk for Data on Kubernetes as well, and one of our lead engineers. I could not do this talk without him, so I want to make sure he got some nice credit. So what are we going to talk about today, though? First things first, I'm going to give you a quick intro to Apache Cassandra, what it does, kind of how queries come in, and the highlights of why Cassandra is an interesting database. And then we're going to talk about Astra Serverless, which is this version of Cassandra that we've developed to run cloud natively and really with a bunch of the components of the cloud native ecosystem. We're going to map out how those components all relate to each other. And then finally, we're going to look at the life cycle of what we call a CQL request. CQL is the Cassandra query language. Think of it like SQL. But just how you would, how the queries move through the system and all that. I have a QR code up here for the Astra white paper. It goes into a lot more detail, has some really cool diagrams to kind of show how all these systems work together. Highly recommend you go check that out. But let's get started. So first and foremost, the architecture of Cassandra. I got started with Cassandra back in 2013. I went to a Cassandra summit out in San Francisco, and it actually changed my life because I was just doing app development work back then. And now I've been working with Cassandra, well, ever since. So at its core, Cassandra assumes it's running on a fixed, I don't want to say budget, but a fixed group of hardware. Certainly you can add and remove nodes. Nodes will go down, nodes will come up, what have you. But there's a bit of a process involved to add a node, remove a node, what have. So for the most part, at any given time, your Cassandra is running on a fixed set of hardware. All nodes can do all things. It's peer-to-peer, so there's no primary and replicas. It's all, you can ask any node to service a query, and if it can't service that query, it'll pass it along to a node that can. We'll have some diagrams for that here in a second. You can't independently scale the components, though. And what I mean by that is, if you think about data, compute, network, with data being more like storage, compute, and network, I can't just say, give me more of the processing side of this. I have to add another node, which is also going to increase my storage capacity and what have you. If I need more storage, I have to add more nodes, regardless of the fact that queries may be running just fine. All the nodes talk to all of the other nodes. If your driver will also open a connection to each node in the cluster. So there's there's quite a bit of networking involved. And one of the key points when we talk about serverless infrastructure or how to make something a bit more scalable, we tend to think of multi-tenancy. And Apache Cassandra doesn't do that out of the box. You can have separate key spaces, but there's still a limit on like the total number of resources available to a cluster. And I can't just say, I want to scale out this cluster for just this one user or just this one key space. When I scale out a cluster, it affects all key spaces, usually in a good way. But if you're talking about budgets from different lines of business, that kind of thing, you don't get that independent scalability. Many users get around this by deploying separate clusters for various lines of business or various applications, but it's just something that you kind of have to think about. And then does not auto-scale. There are metrics that you can watch, and you can write some tooling to do that automated scaling. But like I said before, adding and removing nodes can take a bit of time. Oh, of course, my laptop screen just turns off. My apologies. It can take a little bit of time, so you could see, I've seen nodes that are multiple terabytes in size. Adding a new node to that cluster can take over a day. And so auto-scaling, while possible, is going to take a significant chunk of time and resources, and maybe even some automation that you have to write. So let's talk about a Cassandra cluster. I said all nodes are created equal. Here we have 6 nodes. I'm going to just give it a name. This is in Data Center 1. Each of these nodes has storage on disk. Each of these nodes can receive queries. We also have what's called a replication factor. So any piece of data that comes into the system is going to be replicated across 3 nodes. So that's the first view. But let's add some application servers because it does make sense just to talk about a database. And then let's talk about a query coming into this cluster. So if we have a query coming from our app server, it goes into this node over here on the left-hand side, well, the left-hand side of the ring. That node is a replica, and it's forwarding that data request over to other replicas. If this was a read request, this node would receive the request from the client. It would ask for the data on the other replicas. It would make sure that everything makes sense, fix any inconsistencies, and then send it back. So essentially, whichever node receives that request is known as the coordinator node. It's responsible for coordinating that query. Any node can be a coordinator. There's some smart bits inside of the driver to make sure that we route directly to a replica to avoid extra network hops and all that fun stuff, but just at a high level. Now, if I, for some reason, choose a coordinator node that doesn't have data, you can see it still says, oh, I know where that data lives, and forwards it to the appropriate nodes. We can all see that? Yeah, we can all see that. So this even works in a multi-data center cluster. Cassandra is multi-region or multi-DC out of the box. So here I have a single Cassandra cluster that's separated across, let's just say, 2 regions. You could have something in the EU, something in the US, and it'll replicate data. So here my application server is talking to DC1. It says, hey, I'm going to replicate my data to these 2 other nodes, but I'm also going to forward this request across the WAN to my remote DC, pick a coordinator over there, which will then be in charge of pushing the data to the appropriate replicas. This can happen synchronously or asynchronously. The developers, application developers have a choice on how that all functions. But it's kind of important to understand this kind of request flow, because when we talk about serverless, we're going to follow this same request flow and how it moves through the system. So when we first started talking about scaling Cassandra, though, we created this project called Stargate. And Stargate effectively removed that coordination job from the Cassandra cluster itself into a stateless layer in the center. That way we can, as we scale out the number of app servers, we can independently scale the compute or the query side of things while leaving the data side independent. And Stargate plays a big role in how we started to think about destructuring Apache Cassandra as a database into multiple components. So how can we make Cassandra serverless? Or really, how can we shatter the monolith, if you will, of Apache Cassandra? So we said, if we wanted to make a serverless Cassandra, we needed to be able to scale across different axes, whether that be scaling data independently of the number of coordinator nodes, scaling the number of coordinators independent of the data nodes, right? Reads versus writes, depending on what kind of workload we're seeing, we can scale maybe types of instances or storage options. We also wanted to be super elastic. So I mentioned it can sometimes take days to add or remove nodes. That's not really elastic in my eyes. I want to be able to add servers in minutes, not hours and days. And then finally, we've been looking at the Kubernetes ecosystem, and we actually started our database as a service model on Kubernetes, where we were just running Apache Cassandra processes inside of containers. We said, there's a lot of stuff in this ecosystem that we could be leveraging to make this a better experience and maybe fix some of the issues we've had in Cassandra for years now. And then finally, have some operators that could aid us in doing these types of deployments and ultimately coordinating all these services. So, but why would we want to do this? We want to use established cloud components, whether those are ones that we're deploying that are part of the cloud native ecosystem or ones that are coming from our cloud providers like object stores, load balancers, that kind of thing. Again, we wanted to separate that compute from storage and split the separate storage engine components of Cassandra into smaller scalable services. When we have some of those here in the bottom right of the slide, I'm going to go into what each of those does and why they can be independent and what being independent brings to the table. And we said for a database as a service company, what does this give us, right? Well, we can transition from capacity-based pricing to usage-based pricing. So in our initial release of Astra, you would just tell us how many nodes you wanted or how much storage you needed. We provision a number of nodes and away you go. Now we can just say, we'll get you whatever resources you need. We'll scale to meet your workload, both up and down. That helps with unit economics from our side as we're trying to run it on a reasonable amount of hardware, right? Versus a lot of hardware if we're using the previous model. optimize performance, and give us a better operational story. So let's talk about the serverless services. So I mentioned Stargate previously. That works with open source Cassandra today. It works with paid Cassandra offerings that DataStax has called DataStax Enterprise. And it's interesting because it started as just a Cassandra node that was told, you don't want to join the cluster and have any data, but I want you to connect to all the other nodes in the cluster, and if you receive like a query, you can process that query. You just don't store anything yourself. And we layered a bunch of API services on top of that too, so HTTP APIs with REST, GraphQL, this document interface. And then we said the data service, though, is what these, the half of the node that wasn't doing coordination, it was just talking to disk, writing SS tables to disk, putting bits of data inside of memory, reconciling when data was out of sync, and ultimately serving up saying, hey, this is the data from my replica. The compaction service is pretty fascinating because Apache Cassandra uses what's called SS tables. They are immutable by nature, so as soon as they're written to disk, they're never updated again. The downside to that is you have to get rid of old data as it's overwritten. So we have a process called compaction that takes many of these SS tables, compacts them together, getting rid of old data, and making sure everything stays in sync. So we took that out of the replica itself and made that its own separate service. There's some gotchas with doing that. We can talk about it here in a second. Next, we had this metadata service, and this is kind of fascinating. So one of the gotchas with Cassandra is when you get into larger clusters, things can get a little weird. I was working on a 300-node cluster for a customer, and when we would run a table change, it would take a little while for that schema to propagate around the cluster. So I'd say, hey, you have a new field in this table, and I'd run this separate command, and I could watch and see, okay, these 3 nodes now have the new schema, 4, 5, 6, okay, it's done. But if you didn't know that you needed to wait until it kind of had consensus, and maybe you put all of your schema updates inside of a single file, you may send a command to add a column to this node over here and send a separate command to add a column to this node over here for a separate table. And now you have 2 different versions of the schema. And in some cases, it can reconcile that and get back to a good state. In other cases, you have to do some command line wizardry to fix it. But that's no fun. So whether that's not being able to push a bunch of schema updates at the same time or having to just kind of wait between all these steps was frustrating, right? And so one of the things is we moved that metadata service to etcd. And said, hey, we're going to do our schema updates with etcd. It's going to give us that consistency that we're looking for. And we can also watch it for updates at the node level. So we actually ripped that part out of Cassandra. We also do some topology work with that, looking for when nodes add and join the cluster or are removed. Again, we can subscribe to those updates, and we don't have to maintain that ourselves. Being that Cassandra predates Kubernetes, it had to evolve some of these things over time. And it's interesting to see where some of what we've done has overlapped and also where the communities have kind of diverged. And then finally, object storage. We said, hey, storing all this data on disk is nice, but it can be A, expensive, and B, if you're not touching a lot of this, it can be stored cheaper elsewhere. So we said, why don't we look at object stores as a method to do that? And then finally, operators, just to make the operational life easier. I've written a lot of Ansible and Puppet and all this code to manage on-prem Cassandra clusters. I've also written a bunch of operators for it now, and I tell you, the operator lifestyle is pretty awesome. Make me a cluster, and it's like, okay, I got you. So we wanted to embrace that. So if we zoom out a little bit, these are all the services that we have inside of our serverless environment. And you can see a number of these are highlighted in orange because they are cloud native specific, part of CNCF, or adjacent, if you will. Metrics and Grafana are not part of the CNCF, but they're in the Prometheus space, and that's actually where we started. So we're using like Nginx for ingress and working with SSL. I mentioned etcd, but we have all these other services too. And because we are separating all these out, we can manage them independently, scale them independently, and that results in a better experience for our users. So if we go back to looking at the services map, we can see kind of how these layers are all working together. So we have Prometheus up to the side here, actually monitoring a number of these layers. We have Kubernetes operators that are managing the life cycles of those layers. etcd in our API server is, again, that metadata information. But Now our user app is going, if we kind of traverse the stack, we can see our user app talks to our CQL driver, which is just the driver within your application, goes over the internet or a private link into Nginx. You're connecting with a certificate bundle, so we can say, hey, this request is coming in for this particular tenant inside of our multi-tenant system. We can make sure you're routed to the right location and that you have permission to access those resources. From there, we use OPA and validate that you have permissions to that particular table with that particular type of operation. And it goes down through Stargate. The live data that are on our actual containers that are running and the various caches that they have. And then if the data isn't present on one of our data nodes, we can actually go out to S3, pull it in. That doesn't happen that often. It's mostly just when you create a new instance. And then the separate cleaners, and then this regional service, which we'll talk about when we talk about the life cycle of a request. So the CQL request lifecycle. So here we have number one, a CQL driver is coming in. It has a secure connect bundle attached to it, which is that SSL information I mentioned. Inside of that bundle, there's a number of certificates. There's a key store and a trust store. So the driver knows, in this case, we're talking about Java, so how to process those certificates and which ones to trust. That hits Nginx, and Nginx, the first thing it does is says, hey, is this a valid certificate, and who is it for? And we're just using SNI for that. If you think about, so all this traffic is happening over TCP. If you think about a lot of the ingress that you see in Kubernetes, that's mostly HTTP, and you can provide a lot of context with headers. With TCP traffic, that's not really the case, except if you're using TLS, you can have that SNI field as part of the connection to do interesting things. In this case, we're doing some routing. But anyway, from there, we validate the certificate. We say, hey, are you even allowed to talk to these services, even though you have a valid certificate? Is it for the services you're trying to talk to? That'll go in and hit our Stargate layer. Stargate's pretty fascinating. I mentioned the API services and that it speaks native Cassandra, but it's also extendable. So we extended the version that we're running inside of our serverless to reach out to OPA and do that validation. So it decodes the request, says, hey, this token is trying to do this read against this database and this table. And OPA says, yeah, good to go, or no, and that's not going to happen. Stargate, again, is all about the coordination tier. So it'll actually send the request to the data nodes that are involved with that particular query. It's not just one node, it'll be multiple replicas on multiple containers. Make sure that all that's correct. Send a message over to FluentBit, which we're using for billing. So just say, this is the type of request that we run, a read, a write, what size it is. And then finally, that goes back to the end user. But I do want to highlight a number of the pieces that are shown here underneath S3, because previously all this was happening on those same nodes where you're running your queries. So if we think about the Cassandra node I showed in the beginning, it was doing coordination, it was doing data storage, but it's also doing this compaction, making sure that we don't have a bunch of files on disks that don't need to exist there anymore. Because all our data is replicated out to S3, we can now have a out-of-band compaction process that does not affect the performance of our data or our coordination nodes. So that's one of the big tuning issues you have inside of regular Cassandra is you say, hey, how much storage throughput do you want to give your compactors? Because if you go too heavy on that, you're taking away resources from your ability to answer queries and ultimately affect your latencies for your end users. Well, by removing that from this CQL lifecycle at all, there's no way for us to impact the lifecycle of a query. And when the compactor is done, S3 is updated, we can send a signal out that says, hey, nodes, if you have this, if you're responsible for this part of the data range, go ahead and pull your new SS tables. They're ready for you. You can recycle these old ones. And then separately, we have a cleaner service to, again, look for data that is no longer relevant, that can be deleted, and updating the metadata. So here, the compactor is going to say, hey, I've made some updates, push it to the etcd server. That's going to get pushed back to the data layer. Data layer will rehydrate itself off of S3. The other nice thing about this infrastructure is as we scale out the number of data instances, they're going to pick up freshly compacted data or whatever is currently relevant. They don't need to stream all the data from the other replicas that are online. And that results in a faster boot time for new instances, which, as we mentioned, elasticity is a big deal here. it's a little different for multi-region requests. We still do all those things we did before, but now there's also this region service. So our data node here, A3, is going to go ahead and forward that request across the WAN to our remote region, where all those things are. It's again going to hit the Nginx layer and then go down and to the data layer inside of that that region. But we also have these repair processes that are saying, and a region service to say, hey, in case you missed some of these queries, maybe a pod was going down or there was a hardware issue or whatnot, we still push that information over the wire asynchronously to make sure that those remote regions are kept in sync. And that's it. So if you're interested in checking out Astra, it's at astra.datastacks.com. I've got a $200 credit. Usually it's just $25 credit for the free tier, which is millions of reads and writes, gigabytes of data. It's kind of ridiculous what goes into it. It all depends on the size of your request and all that sort of thing. So I can't just say definitively it's this, this, and this. It's all about the type of application that's talking to it. But feel free to check it out. And then I had a link earlier to the white paper that kind of goes into some of the more specifics as we develop this out. So any questions about what we're doing here? Yeah, go for it.
So going back, you go back to slide 20,
yeah.
please. Okay.
This one?
So yeah, so it's pretty clear how it's decomposed and the approach you follow in terms of architecture to simplify the nodes, as you said. But it seems that compared to the data nodes or the data pods, the rest is peanuts. So I mean, which are the challenges you're still facing there? Because at the end of the day, the size was defined by the amount of data that the data nodes were holding. So which are the challenges you face in looking for the right spot in terms of how to split data in many? I don't know you follow that.
So if I'm going to go back to
I'm talking in terms of performance later on for queries, because you move from being in a reduced number of nodes to a huge number of pods holding data services.
Yeah. So one of the things that we found is a number of our users are actually bound at they are contending on resources at the coordination tier and not at the data tier. So if all these things are living inside of a single ring here, what we would find is maybe a node has a request come in and the data is really out of sync. So it's got to send a number of updates to the other replicas before it sends the information back to the user. And that was cutting into its time processing a replica request from another node. So they were the compute side and the storage side were actively competing. And so just moving that coordination tier to its own level away from the data nodes, it could focus on just pulling its local data off of its local disk. And one of the side effects of that is we can actually have denser data nodes. They don't need to be limited in size as they were previously, because they're not fighting for those CPU resources or in some cases disk resources. That being said, because we actually we push the data out to S3, when we go to bring up, let's say we see a particularly hot partition. So one particular partition is getting more traffic than the others. We could scale out the number of data nodes for that particular partition or set of data and increase its throughput that way. Or even break it up a little bit too. So we can say, hey, this partition has this data range has two really hot partitions. Why don't we split this in half and give them separate resources to work on?
Okay, so you're doing like some kind of tiering with the data partition.
Yeah, so we can look at the throughput at the Stargate layer and see which partitions are being more active and scale in that way. One of the other nice things about having these independent tiers is all of our metrics are going back into Prometheus, and we can look at the performance of individual sections and use that as input into our scaling operators to say, hey, let's go ahead and adjust this dynamically instead of saying, oh, hey, we're hitting a limit, increase the number of nodes. We can say, this is the particular limit we're hitting on this particular data range. Let's scale in that space. So maybe Stargate's fine, but data A3 needs to be split into two more data sections, what have you.
Okay, last question. Having been involved in the past in operator-related development, I see a lot of components. How is your operator in terms of maturity? Because I see a lot of stuff to be controlled there.
Yeah, so we have a number of operators in play here. It's not just there's not just a single operator. I know we're showing the installation operator here, but it's growing. our use of operators and the capability they have to act autonomously versus requiring some sort of human operator input. So here we have like our tenant operators, which are updating metadata around which Stargates are attached to which data nodes are attached to particular tenants. And then we have other operators that are saying, okay, you're in charge of not necessarily those relationships, but the instantiation and creation and realization of those services. We've been writing operators for 3, maybe 4 years now. We started with just, hey, I want to run Cassandra on Kubernetes. This before we did our serverless stuff here. And we've taken everything we've learned over time and kind of leveled up. Actually, in the Cassandra project I work on, we now have a multi-Kubernetes cluster operator. So you can run, our Kubernetes clusters tend to be DC bound or region bound. So you could have 2 regions with a single Cassandra cluster that spans them. And we have an operator that handles pushing those resources to the control planes inside of each of the Kubernetes clusters. And so we're leveling up in that space as well. And it's interesting to see the evolution there.
Really, really cool work. Yeah, thank you.
Awesome. Any other questions? No? Okay.
Okay, great. Thank you.
Wonderful.
Nice to meet you. Thank you for joining me for this talk. My name is Shauli, and I'm the CEO of Armo, and we're going to discuss what we've learned from scanning over 10,000 Kubernetes clusters using KubeScape. KubeScape is an open source tool that we've created. I'm going to talk more about it as we go forward. Just a little bit about myself. As I said, I'm the CEO and co-founder of Armo. I'm a software developer turned into entrepreneur. In my life before that, I'm a software engineer, worked in a few companies, and I'm a very big fan of surfing, and you see me there on one of the waves there. And this picture was taken pretty much 5 seconds before I completely fell on my face. So it looks good, but the reality was much different, as we always have with reality versus pictures, right? So you seem to be the audience that I don't need to convince that Kubernetes is here to stay and is becoming the de facto cloud-native operating system for everything related to containers and managing containers. But the numbers shows that 96% of organizations are either already using or are evaluating the usage of Kubernetes, and over 5.6 million developers are using Kubernetes worldwide. And that's 31% of all backend developers, and it's increasingly being used in production. And this is a very big change that has happened in 2021. If you think about what happened until 2021, Kubernetes was all over development environments. Everyone was experimenting with it, but it moved into production workloads and into production environments during late 2019, early 2021. And that's also where it got off the radar for attackers and for researchers. If you think about what happened in 2021, there were so many vulnerabilities that were found in containers, container runtime, and Linux that impact your ability to run Kubernetes safely. And this is just because it became more popular. It became more popular, people experimented with it more. Honestly, we don't know about many breaches that happened on Kubernetes, but a lot of research into vulnerabilities has gone into it, and usually that happens right before the first attack happens. So this is still yet to be seen. And you know, we feel at least that Kubernetes security solutions, they fail to provide a DevOps experience or developer experience. I guess many of you here are not CISOs. You are developers or you are DevOps engineers. And what I want to tell you guys is security is coming your way. Security is shifting left. I can tell you when I speak with a CISO and I'll tell them, I have a Kubernetes security solution to propose to you, their first reaction is, okay, I need to get my DevOps involved, because they don't know nothing about Kubernetes. They just see a mess. They just see a lot of things going around, and they don't understand what's going on. And what we see is a big shift in the market towards developers and DevOps owning and engineering teams owning security. And that's why we've created KubeScape. This is more data. I don't want to dwell too much on it because we only have 30 minutes. But basically, some of the data here that people are releasing release cycles weekly. 26% of the people responded to this Red Hat survey do a release cycle of a weekly, and only 7% are quarterly. This is a very big change from a long time ago. But to go to what I just spoke with you about, what role at your organization is most responsible for containers and Kubernetes security? And 27 people, so 27% of organizations put DevOps or Ops into the answer there. And there is also DevSecOps, right? 18% DevSecOps. We'll talk about this function because it's a new function, and I don't really know, honestly, what is the difference between DevSecOps and DevOps and how they work together, and we can talk about that. In terms of what is concerning companies and engineers around security for Kubernetes is, first of all, misconfigurations. 60% worry about misconfigurations, and 32% after that are worried about security incident happening in runtime. Gartner thinks that by 2025, 99% of cloud breaches will have a root cause of a misconfiguration. And I don't think that's, it might be extreme, but it's not imaginary. Because just think, if you're using Kubernetes or you're using cloud, just think about the amount of configurations that are going on and the misconfigurations that can happen in all of the different YAMLs that you basically dump into your cluster, and many people don't know what's going on there. So what we did, we developed KubeScape. KubeScape has already scanned over 15K clusters. We did an analysis on the first 10 that we're going to talk about today. It's on GitHub. It's completely open source. We have a SaaS version that we, of course, encourage you to use. But the project is open source, and we're going to actually increase the open source part of it going forward. It already has close to 6,000 stars on GitHub, quite a few contributors, and we're trying to expand. So you're welcome also to contribute. And everything I'm going to show you today is an output of KubeScape. Basically, what it does, you download it, you point it in a cluster, and you get a risk scan of that cluster, both for vulnerabilities and misconfigurations. This is the main functionality that you get. Risk analysis and compliance, basically comparing the status of your cluster against different best practices. The most prolific one that we've seen, the most interesting one that we've seen, is the NSA and CISA guidance. The NSA issued guidance into how you should work with the Kubernetes security environment. We basically took that document and made it into a framework that you could get pass-fail on every test on that framework. We added image scanning because many of our participants asked to connect the misconfiguration to actual vulnerabilities. Of course, if you have a misconfiguration on a vulnerable workload versus non-vulnerable workload, it makes a difference. And finally, RBAC Visualizer. RBAC is the latest thing that we added, which basically maps all the role-based access control that you have in your Kubernetes environment into something that you can digest, that you can see. Because basically, ask yourself, what are the different roles and permissions that I have in my role-based access control? What you're going to need to take is a ton of different YAMLs and role bindings and role and privileges and combine it together. So we did it for you. So that's what we did. And we put it all in a single pane of glass that you can see it in a very useful manner. So what does the research show? So we have scanned over 10,000, not we, our users scanned over 10,000 different clusters. 48% of our users are coming from the North American region. About 33% are from Europe, and the rest from the EMEA and APAC. 57% of the users who have ran KubeScape, the title that they provided was DevOps, and 24% were security engineers or architects. Everyone using KubeScape is an hands-on guy, okay? No CISO or even not a security analyst is going to run KubeScape because it needs an understanding of the environment, and it needs the developer capabilities. We talked before about DevSecOps. We have 5% DevSecOps. And in my mind, this is just an indication that the title DevSecOps is just not used enough. Okay, because in my mind, those 57% DevOps people who ran KubeScape, why did they do that? It was because they were interested and they were concerned about the security of their environment. So in my mind, they're already DevSecOps in some of what they do, right? So it's kind of like, in my mind, the title thing is going to change a little bit soon. In terms of an environment, how many clusters and how many nodes within a cluster do people use? So we see that the 42% of the users have one cluster. I'd call those people who experiment with us. About 33% have less than 4 clusters, and only 3% have 25 clusters and more. If you're an organization and you have more than 25 clusters, you have my full empathy. It's a very problematic situation to be in, and, or a very good one, I don't know. In terms of cluster size, most of the clusters have below 10 worker nodes, and about 6% of the clusters, of the 10,000 clusters, had more than 50 nodes. This is something that we see more and more. And there is always a debate whether to use many small clusters or one large cluster, okay? I'm a one large or a few large clusters kind of guy, okay? Because I think the control plane of Kubernetes by itself is so complicated and also heavy in terms of resources that it requires, that I would like to limit the number of control planes that I have. However, if you do use one cluster, what we've seen is you should use many namespaces. Because we've seen one namespace with 1,000 pods, usually doesn't work very well in terms of complexity. So how do you do that? It takes 3 minutes to get your first scan. I'm going to show you how to do that. Megan actually encouraged me to do that. So I'm going to show you how to do that right now on the spot, just so you see how it goes. Usually, we start with the GitHub page. Our users go to the GitHub page, and there is an installation instruction here. You basically take the install script, and we pipe it into bin bash. I know some people don't like piping into bin bash. What am I running? But it's open source, so you can look what you're running. I'm going to copy it here, and I have a GKE account that is here. Okay, if I do kube control get pods, I have something running here. Okay, maybe it doesn't like that. Yeah, space. Okay, and now I'm going to paste the command I just copied, and I'm going to run it. Basically, it downloads Kubescape and installs it as a CLI right here on my machine. And since my machine is pointed with its kubeconfig into this cluster, if I run Kubescape now, it will run it against that cluster. So I'm going to run Kubescape scan framework. I'm going to do the NSA framework, and I'm going to run up. Yes, because no one uses capital letters these days. Okay. Now it's accessing, and this is the result. So we get all of the different controls that have been created for the NSA framework, and we get a pass-fail and the number of resources that failed each. I could use the verbose mode, and then it will give me for each control exactly which resources failed that control. And it also gets me into the UI where you can register to our SaaS, and then you basically get the same results with a little bit more functionality, but you get it in a more organized way. It will get you basically here, where you can see that I have the NSA framework, and I have all of the different requirements, controls, and what passed and what failed for each one of those controls. So that's it. I think we spent about 3 minutes on getting the results and seeing it in action. As I said, we have about 5 different frameworks to work with, but there are 4 that are most popular. There is the NSA framework. There is the Midway attack framework that was adjusted to Kubernetes actually by Microsoft. There is the Armo best practices framework, which we have created. Basically, what we did there is we took from Mitre and from NSA the top priority and the most important ones that we felt are important. And there is the DevOps best practices, which basically adds on top of security some regular best practices. So for example, using a probe, using a liveness probe in every microservice, right? It's a very good best practice. It's not really related to security, but you might want to know which workloads in your environment don't have one. So readiness probe, liveness probe, those type of things are in DevOps best. Now, what we've seen, we give you a score. We give your cluster a score. The higher the score, the worse you are in terms of your situation. It's a risk score. And our best practices, what we've seen based on the data, is that you should keep your score below 30. If you're below 30, you're in a relatively good position. If you have a risk score above 60, okay, you are in the worst 5% of the 10,000 clusters of our sample size. If you have a risk score below 10, you are at the top 10%. Okay? So that's kind of like to give you a benchmark of what you should look for. And if I go back here, you can see the scores right here, and you can choose which ones you want to see and which ones you don't want to see. In terms of the top 5 security misconfigurations that we have found. So first of all, before we go to the actual top 5, 100% of clusters had a misconfiguration in them. Now this, while this is alarming, it's not as alarming as it sounds, because some misconfigurations or things that the system would consider as misconfigurations are actually intended, right? So for example, running a privileged workload, right? It's a very bad practice, but some workloads need to run as privileged. So it's not surprising, and I would say that if you need to think about actual misconfiguration, probably 70% of clusters had one or two, more than one of those. 65% of clusters had high severity misconfigurations, and 50% of clusters, that's the cutoff point. If you look at half of the clusters, had 14 or more misconfigurations. Now, the top misconfigurations are running privileged containers, using cluster admin binding, missing resources policies, basically limits on resources. I'm going to talk about it in a minute. Immutable container file system, very, very popular. Basically not using immutable container file system, and not blocking ingress and egress on a pod with some kind of policy. So those are the top. And stop running privileged workloads, that's the first one that I would say. And when we talk about privileges, there are 2 ways to get privileges. And one is using just the metadata privilege true. Okay? If you use privilege true in your container YAML, you basically cancellate the notion of container. Okay? You give anyone in that container access to the entire host. You basically break out of the namespace. And the other thing you can do is, something you shouldn't do is to run the user within the container as a user less than 1,000, which is a root user or user 0. So we recommend running as user 1,000 and more. Are you familiar with that? Make sense? Now the difference is that if you do that one on your right, basically it means that you're running a root process within the container. But if privilege is false, that root user will not be able to go outside the container. It's root only within the container. If you give it privileges, it also can go outside of the container. So using privilege false is a very good best practice to start with, but then also removing root is the second one. Now, here's a pop quiz for you guys. If you do run as user 0 and the privilege is false, it's quite easy. It's easy to understand the outcome. The outcome is the root process that is in the container, but it doesn't have capabilities outside of the container. What happens if you run as a user, not as a root user, but you give it privilege true? So technically, a non-root user could be going outside of the container, or couldn't it? Do you need to be root in order to actually utilize the privilege that you've been given, or not? And the answer is that I'm not going to answer that. What I'm going to do is anyone here or anyone in the streaming who sends me an email or a tweet or whatever with some information on that or the answer to what's happened in this situation, will give you 100 points to our swag store. Okay? We have a very cool swag store that you can use to buy hats and bags and water bottles or anything like that. Or a t-shirt, whatever you want. So shoot us an email and or LinkedIn or whatever, Twitter, and you'll get that. Privilege, the problem with privilege container has made all of the vulnerabilities that were found in 2021 extreme. So basically, if you just did that, if you just stopped using root users and privileged containers, 90% of the vulnerabilities that have been found in 2021 would not be exploitable in your system. They required those privileges in order to be exploitable. And this is just an example, the 04921, privilege escalation and container escape. 63% of users have used workloads that were exposed outside of the cluster without ingress control. This is, of course, very problematic, a workload that is completely open to the internet. And here you have the YAML and how to change that. You basically need to add the block element. By the way, if you go to our system, not only our system, our docs are available for everyone. I'm just going to want to show you something here. This is off script. But for every one of our controls, let's say, privileged container, for example, we have a documentation that explains to you exactly what it means, what the remediation is, and how to solve it with an example. And this URL, hub@armo.cloud, is available for anyone. So you don't have to log into our SaaS in order to get that. You can get that directly. Limit resources. 63% of clusters did not run with the proper memory and CPU request and limits configuration. Very, very good practice, not only for security, but also for finance, FinOps, resource utilization in your organization. It is very important to do that. What we recommend, actually, you can even integrate Kubescape into your GitHub. We have like a GitHub Git action extension. And this is really nice because you can say, for example, every YAML or every configuration that is pushed into this Git repository, run this test and tell the user, tell the developer, the actual developer, that it did not put limit resources and they can do it right there. So that's one thing that you can do. The way, just to show you how it looks like. So if we go back here, let's take this privileged container as an example. If I click on that, I can see that I have different workloads that are running as privileged. You can see that, I don't know if you saw the number here, it shows 1. Okay, even though if I look at things, I can see that there are more than one. There is like the PDCSI node and all kind of others, but those are all in the Kube system. And unfortunately, those need to run as privilege. If you take the privilege away, you will mess up your cluster. So they are marked as an exception here, just so we won't alert on them. Okay, you can decide that you want to get those alerts, but it's usually just rubbish. And then there is this deployment in the default namespace called recommendation service. And if I go into that, I can see that it does not have the proper resources. I'm sorry, this is a privileged container. So I can see privileged container is failed, and it says line 69. It gets me to line 69, and I can see exactly that privilege is true. I can have, there's a little note here about how to fix it, and you can copy the object and download the YAML in order to push it back to your CI/CD in a fixed manner. 37%, which is, it's not 60%, but it's still very problematic for this specific problem. 37% had cluster and applications with credentials in the configurations files. Think about access key to AWS, access key to S3 in the actual configuration file of the workloads. Of course, very, very problematic, but actually very understandable. If I'm a developer, it's the easiest place to be. Of course, better to use Kubernetes secrets or something like that. Again, if you look at the way we show it to you, just to kind of like show you where we came from, very, very similar to what I just showed you. Let's look at application credentials. Here you go, application credentials in configuration file. So we have here another service. And if you go to line 34, we can see that there was an AWS secret access key in this configuration file. Now, we do not take the key out, right? We don't want to take users' private data or secret data. So we kind of like put those, we obfuscate it. But you know that this is where you have that problem. If you want to send this to us, we allow it to you, but on default, we don't take it because we don't want to expose you to that risk. And then I think finally, the last one of the top 5 is running with dangerous Linux capabilities. This is, for me, a subset of the privilege and run as root type capabilities. We define two different capabilities. We define dangerous capabilities and insecure capabilities. In our mind, like just in terms of our terminology, insecure is worse than dangerous. And this is the list of capabilities that we check for. And this is, and the ones that are in red are ones that we consider even more problematic. Of course, the netadmin, sysadmin, those type of capabilities. That makes sense? Any questions there so far? Cool. Up until now, we talked solely about misconfigurations. Now we are connecting that to vulnerabilities, okay? We scan the images running in the clusters for vulnerabilities, and what we've seen is that 44% of the vulnerabilities were medium to low, about 21% were critical, and 35% were high. And the number of critical vulnerabilities in the clusters, 64% of clusters had no critical vulnerabilities, okay? 17% of clusters had 1 or 2, 13% of clusters had 2 to 5, and 6% had over 6 critical vulnerabilities. If you look at that, if you don't consider the extent of the vulnerability, just vulnerability in general, 63% of containers had at least 1 or more vulnerabilities, and 46% had 1 or more critical vulnerabilities. This is what I just showed you. And 53% of those containers had RCE vulnerabilities. So we look further into the vulnerability, and if it's an RCE, remote code execution vulnerability, we give it a we note that it is a remote code execution vulnerability. We believe that's a bigger problem, right? Because by definition, it can be exploited remotely without access to your node. You can see it here. If you go to image scanning, so you see that, for example, in this environment, this is more than one cluster. We have 85 critical vulnerabilities, 230 high vulnerabilities. This is, of course, a very bad environment. But if I filter it, I can see that 27 of the critical vulnerabilities are also remote code execution type vulnerabilities, very problematic. And I can also decide to see which one have fixes. So 45 of the 85 actually have fixes. You should probably go and fix those. Now, if you look at the top 5 vulnerabilities found, I don't have the names here on purpose, and I'll show it in a minute. Unfortunately, to be very, very honest, it doesn't give you a lot of insight. And why is that? Because it is not really the vulnerability as much as it is the library that it is in. glibc is, of course, one, it's the library that is used in any of your workloads. So any vulnerability in that library will be all across all of your workloads, and that's why you see all of those. The one that was kind of surprising is the libpcre. Do you know what it is? It's a regular expression, a Perl regular expression analyzer that enables you to give Perl type exception into Linux, blah, blah, blah. Long story short, I was surprised to see it there, but it was there. To kind of like bring everything together, vulnerabilities will always be out there, okay? But as I said before, and I know we're at the end of our talk, and that's what I wanted to speak with you about and to leave you with, is being and having the right configuration will make you unexploitable by many of the vulnerabilities that are out there. Whenever a vulnerability comes out, this is, for example, the 0492 it made tons of noise, okay? Tons of noise because it was very easy to exploit. But if you did if you looked at the control number 16, allow privilege escalation, and you denied running as root, and you did not have insecure capabilities, cap, duck, override, it will not be able to be exploited. So every vulnerability requires you to have different misconfigurations, or I would say loose configurations in your system. And each one of those, just one of those not being able would solve this problem, okay? So that's what I want to leave you with. And, we have, I don't know if I'm allowed, but we also have a booth here at KubeCon, and I would welcome you to come, and get T-shirt and stuff and talk more with us. And and we would love to engage with you and get your feedback. So thank you so much. I really enjoyed it.
Are there any questions?
Yes.
So, which tool are you using to analyze the containers? Like, for example, Aqua System using 3B, things like that?
Yeah. So the tool that is used to scan for misconfiguration is our tool. It's open source and you can use it. It uses OPA, the Open Policy Agent, as part of it. And the reason we wanted to do that is we wanted the community to be able to add more controls. So the Rego language is very easy to use, and you can contribute more controls using that. For image scanning and vulnerability scanning, we are using Anchor.
The other question is, I see that you have your own SaaS.
Yes.
Are you going to release, like, somebody can run this SaaS in its own cloud?
Yes, this is a very good question. As I said, it's currently not available, and we are expanding the level of open source and what we are going to release to open source. So there is going to be an option to basically download KubeScape in its entirety and run it in your own cluster as an open source. It's probably 6 months or
Last
so.
question, are you going to create an admission controller for...
Yes.
Okay.
The short answer is yes, because so we, as an open source project, and not just an open source, every company and every project, whatever, needs to be fed by user requirements and user demands, right? So what you just said, admission controller, is maybe at the top 2 or top 3 of requests that we keep getting, and it's definitely going to be there in like 2 months or so.
Thank you.
Any more questions?
Hi, thank you for your presentation and for the tool. It seems quite cool. I would just like to know how exactly does it scan? For example, does it scan only the container, or is it also able to scan diamond set, custom resource definition, and what are exactly the limit of the scanning of the tool?
Yes. So first of all, the way it scans, it's important. You can deploy the tool in 2 different ways. Actually, let me show it to you. So when you decide to deploy the tool, you can decide whether you want to deploy it as a CLI. That's what I showed you. Basically, download an external tool. If you download the external tool, it will be limited by what we have capabilities to do via the kubectl, basically, right? So Kube API, we read all of the configuration, and that's what it's limited for. But you can also deploy it as a cluster, as a namespace, basically like an operator in your cluster. And then it will scan also the nodes themselves. It will look at daemon sets. It will look at the control plane. So we actually have different tests that are defined for the control plane and for specific control planes like GKE, AKS, and EKS. We do not do, at this point, CRDs. The reason we do not do CRDs, it's a little bit hard to understand what's a misconfiguration in CRD because it's custom by definition, right? But we are thinking and we are looking for contributors for specific CRDs. So for example, Istio, right? If you put Istio, it's a CRD, but it's so popular that it might be worth adding tests to it, right? And also there's something that came up from a few users. We did not implement it yet. We don't feel that there is enough traction for that feature. But there was some people who talked about creating custom controls for CRDs, right? So if I have a CRD and I know what needs to be there, I can write a control for that. The reality is that so many people use CRDs and they don't know what needs to be there. Like I would say 80% of the CRDs are just downloaded and deployed, right? Without really knowing what's in there. So that's the problem there. And was there anything else I forgot?
No, I think you answered all.
Cool.
And just one last question.
Yes.
Did you run KubeScape on the KubeScape namespace?
Yes, I did. I did. And the honest reality, it's terrible. Okay? Let me show you. So actually, if you go to the configuration scanning, let's take this cluster as an example. So let's look at, I don't know, this control, for example. I'm sure we will find our own namespace in here. Here we go. So you see the Armo namespace itself as not an ingress and an ingress block. Now, this is not completely our fault because we can't define network policy on our own. But to be very honest, we also have misconfigurations. We continuously strive to fix them, okay? And the more you look at it, you'll see that we have more, less and less, of course.
Okay, thank you.
But we're not hiding it.
Thank you a lot.
Sure.
Okay, thank you very much for your presentation.
Thank you, Evan, for your time.
you for your stamina in staying to the last session in the gallery room. I really appreciate it. And my name is Ann Holler, and I appreciate the chance to talk with you today about efficient deep learning training with Ludwig AutoML, Ray, and Nodeless Kubernetes. All right, cool. I want to start off by just a shout out to people from the Ludwig, Ray, and Alodal communities who've done various work that contributed to this slide set. So including the CNCF blog that we published in February of this year on managing public cloud resources for deep learning training, the Medium blog on Ludwig AutoML for deep learning, which involved tabular data sets, and our Cloud Native Rejekts talk from this past fall on a proof of concept of running Ray on the public cloud. So without further ado, let's get started. So deep learning has been very successfully applied to many fields, including business and science of various sorts. But it's well known that it's difficult to bring deep learning from development into production. Ray and Ludwig are open source systems that have worked to reduce the complexity of deep learning training, scaling, deploying, and serving. But even with some reduction in complexity, deep learning's cost and operational overhead present significant challenges. Deep learning development intermittently requires substantial GPU resources. These resources, cloud vendors are happy to provide them, but at a non-trivial price. And so managing the cost and operational overhead around deep learning is critical to managing deep learning and being able to afford it in a practical sense. Alodal's Nodeless Kubernetes, nicknamed Luna, commoditizes compute for Kubernetes clusters. It provides just-in-time, right-sized, effective, cost-effective compute for Kubernetes applications when they start and removes those resources when the applications finish. So Alodal's technology is targeted at this problem of managing public cloud resources judiciously. So let's marry the two and bring in Ludwig and Ray running on public cloud Kubernetes clusters using Luna as the smart cluster provisioner. So that's the topic of this talk. And so we'll show experiments that using Ludwig deep learning automatic ML training it showed sizable improvements in efficiency and usability running them on Kubernetes clusters in the cloud using Luna versus running them the default way I was doing it before I got educated. So you'll see that it basically lowered operational overhead while improving elapsed time by 61%, computing costs by 54%, and idle Ray cluster costs by 66%, with no reduction in the performance quality of the models. Just a little background information on Ludwig and Ray. So Ludwig is an open source deep learning framework for end-to-end machine learning that supports a variety of things. It operates on a declarative YAML interface, eliminating the need to write code, and typically deep learning requires a lot of code. It scales up to out-of-memory data sets and multi-node clusters using Horovod and Ray. It allows you to experiment with different model hyperparameters using RayTune. We'll talk about that today. And it allows you to serve in production using MLflow. Ray is an open source distributed execution framework that targets large-scale machine learning applications such as the ones that Ludwig is training. It performs automatic parallelization of Python code with minimal code changes to the serial code. It includes many libraries. We'll just focus on the RayTune library today. And it supports deployment in various environments directly onto AWS VMs is one, and of course on public cloud Kubernetes clusters is on another. These are two things we'll talk about today. To continue to push the envelope of decreasing the complexity of deep learning, Ludwig recently introduced AutoML functionality. The idea of AutoML functionality is that you, as the person developing a deep learning model, you just give Ludwig AutoML your data set, the target column you want to predict, and a time budget for doing hyperparameter search. And Ludwig AutoML infers the data types of all the columns in your input data set. It chooses a deep learning model architecture for you. It selects the search parameters and ranges for those search parameters, and it runs a RayTune hyperparameter search for you on Ray tuned GPU workers. And it outputs the best tuned model it found, along with all the models it found, and it returns these models in the form of standard models. So it's choosing well understood models that you'll be able to reason about as the user, and you'll be able to serve flexibly in many environments because they're well understood models. And it returns the training configs that you used to produce those models, so you can, as a human, see what it did. You, as a human, can edit what it did, and these are YAML files that you could then send into the system yourself. The original version that we talked about earlier was for tabular data sets. Just in the past 2 weeks, it's been extended to text classification data sets. So the algorithms that were developed to do this automatic AutoML were developed using thousands of hours of GPU time of model training across 12 tabular data sets. And so these thousands of hours involved running 3 different model architectures and a total of 24 hyperparameters across a wide range of values. And so, you know, after that process was done, an additional 9 data sets were chosen to see if this algorithm could really work on data sets that it hadn't seen before, so 12 new tabular data sets. With those 12 new new tabular data sets after the 12, with these 9 new data sets within a 2-hour time budget, AutoML could give you accuracy competitive with publicly reported, manually tuned models. And I can guarantee you those folks spend more than 2 hours developing those models. So it's a very effective system, and what it does can be leveraged, highly leveraged, by training in the cloud. And so that's the subject of this talk. And the final piece of the puzzle is the Luna functionality for doing flexible resource management for Kubernetes clusters in the cloud. So Luna is a smart cluster provisioner that runs in standard Kubernetes clusters. It's monitoring for pending pod creation requests. It's adding additional compute to those clusters as needed to satisfy those requests. That compute can be VMs on demand or spot. It can be serverless compute like AWS Fargate. And it chooses that compute based on the current availability in the cloud, based on cost in the cloud, and based on other user-specific requirements. You may have requirements around the kind of GPU you want, for example, for machine learning workloads, and you can convey that to Luna. And it's on an ongoing basis, it's monitoring node usage, and it's able to remove compute from the Kubernetes cluster when it's no longer needed. So Luna is comparable to Kubernetes Cluster Autoscaler, but it provides more flexible node selection without the need to create and maintain what can often be hundreds of node groups to have the full flexibility for a particular cloud vendor. It's somewhat similar to AWS Carpenter, but it works across cloud vendors. It provides the ability to do instance family exclusion, and it supports deterministic application of placement rules. So that's the background. Let's go into the experiments. So basically, of those 9 data sets we used to validate the functionality of AutoML, we chose 3 to show the difference between the way I was originally doing this validation and what's possible using the public cloud with Luna. So for those 3 data sets, they were run with a training budget of 1 hour, 2 hour, and 4 hour timeframes. And they were run on a baseline Ray cluster that was deployed directly on EC2 in VMs. And they were run in 2 cluster configurations on the public cloud using Luna. So we will look at these 3 configurations. We'll compare elapsed time, workload, and idle compute cost, and the operational complexity of dealing with these things. And we'll give an overview first, and then we'll deep dive each one. So the top is what I was originally doing. And this is how I validated the 9 data sets. Worked well with AutoML. So I deployed a 3-node cluster directly on AWS VMs. I used NVIDIA T4 VMs because they work well for this workload. These workloads are very sensitive to the kind of GPU you use. This is a very cost-effective GPU for this workload. And you see that the head and the 2 workers are all GPU-enabled, meaning the head can also run a training job. Alternative number 1 is instead of deploying directly onto AWS VMs, a variable size Ray cluster is deployed onto a Kubernetes cluster in the cloud. And that Kubernetes cluster has got Luna, the nodeless technology running in it. And so when that cluster is deployed, it's a variable size cluster, so only the head is deployed. And in fact, Luna goes and fetches a VM that's appropriate to run that head, which is GPU-enabled node. And then as the workload is running, the Ray autoscaler will add nodes to the cluster, the Ray cluster, when they're needed, and Luna will go and find the right compute to add to the Kubernetes cluster to satisfy what the Ray autoscaler is looking for. And when the Ray autoscaler realizes the workers are not busy, it will remove them, and then Luna will remove them from the Kubernetes cluster. The second alternative is just like the first, except the head node is CPU only. So in this case, when the nodes are all quiescent, when there's nothing running in the Ray cluster, there's only a CPU node running rather than having that GPU node running, which is cheaper. So why did I run this way? Why was this my baseline? Well, there's three different things that were nice from the standpoint of someone starting out running a Ray cluster. One was I wanted a standardized amount of compute for the AutoML time budget. So if you're going to run AutoML for 1 hour, 2 hours, or 4 hours, you need to know how much compute backs that up. And so there was a standard idea. There were 3 nodes of a certain type of GPU, and that was the standard for running that AutoML budget. The second is I wanted to control operational complexity. I didn't want to worry about whether I got a legitimate run. I wanted to believe that when I ran for 1 hour, 2 hours, and 4 hours, that the entire time budget had the compute I expected backing it up. And the third thing was I wanted to limit idle costs. So after I would run an experiment, I would log into the Ray head, and I would look and make sure that everything was good, and look at it, poke around, maybe try a few other commands in the context of what was run. So I was pretty sensitive to idle costs. So I wanted to run, one set of things at a time, serially, to control idle cost at the end. And so given all these constraints, G4DN means T4 GPUs, which is what's key for this workload. 4x large had better availability than the cheaper versions. So 4x large is outside of the GPU. It's how much CPU memory there is and so on. 3 nodes, because I knew that that standard amount of compute power could handle the auto-tune jobs, which run up to 10 trials. So I had a good sense that that would satisfy these kinds of time budgets. Fixed size, because I didn't want to worry that I tried to crank up the cluster and the nodes wouldn't be there, like if I used the autoscaler. And non-spot, because I didn't want the instances to go away or I wouldn't get a legit run. And finally, as we already said, a single job at a time. So with this budget, I'm trying to move. Sorry, I'm trying to, here we go. All right, so what happened? So this is our baseline. So at our baseline, of course, as we expect, the accuracy is competitive with the externally reported models. The elapsed time was 22.6 hours. So you might say, well, why wasn't the elapsed time 21 hours? Like 3 times 1 plus 3 times 2 plus 3 times 4. The extra 1.6 hours was setup time where the head loads in the data set and divvies it out to the different Ray workers. And also the best model for each trial is evaluated on the head after the Ray job is over. So that's where the extra 1.6 hours comes from. So running for 22.6 hours on G4DN 4X large, they cost $1.204 an hour. So that was $81.631, and my idle cost is $3.612 an hour. So kind of cool, but it would be nice to not have to wait 22.6 hours for the results. That would be great. It would be nice to have less idle cost than what we saw. And it would be really nice if we could also save some time, some cost on the workload itself. And of course, the obvious choice would have been to run the Ray autoscaler, but I didn't want to do that initially because I couldn't trust that it would find the kind of instances I wanted at runtime, because you have to kind of hard code what it's looking for. But once you move to the Kubernetes world, you don't hard code the kind of instance you're looking for. You just express what resources are needed. And then when Ray autoscaler asks for those resources in Kubernetes, then Luna can step in and grab them for me. And of course, Luna could bring things down when they're not needed anymore. So this is cool, and it's pretty obvious this is going to help me be able to run 3 jobs at a time for 1 hour, 3 jobs at a time, 2 hours, 3 jobs at a time for 4 hours. And so I'm going to save elapsed time, and I'm definitely going to save idle cost. But am I going to save that much during the workload? Like, I wasn't sure how to think about that. Certainly, I'm going to save the 1.6 hours of time that only the head is needed. But what about the other 21 hours? Well, it turns out there actually is a lot of savings there. So one of the things that AutoML does is run the ray tune with this thing called the async hyperband scheduler. And what that does is it looks at the trials that are going on in parallel, and it discontinues ones that aren't giving good results compared to the ones it's already seen. And so as it turns out, it's bringing down a lot of trials of those 10 max trials that are run for an AutoML job. And so you don't really need 3 workers, because once there's fewer than 3 trials left, you don't need 3 workers to run that workload. So if you look here, sorry, I'm having trouble with getting this thing to go forward. Okay. Oh, here we go. That's another way to do it. Okay, so if you, sorry about this. Yeah, it's not moving forward. Yeah, whatever's the most reliable. Those 2? Okay, cool. Thank you. All right, so here's what's happening under the hood. Basically, if you look at this, this is time. So that's the 22.6 hours on the x-axis. And on the y-axis is the data sets, the trials with those data sets. So that top 10 trials is the trials run for the first data set for 1 hour, followed by the next data set for 1 hour, followed by the next data set for 1 hour, and then, oh, I'm running out of time. Okay. Well, I'll try to wrap up as quickly as I can. I got started a little late. So anyway, you can see there that for most of the data sets, not all 3 workers aren't needed the entire time. So moving to the GPU head, the idea here is that we deploy on the GPU head running on, we deploy Ray on a EKS cluster with a GPU head. Luna is running in that cluster doing the auto-scaling, and we set max concurrent trials to 3 so that during that auto-scaling, each of the data sets that's running in parallel will get up to 3 workers, just like it would have in the isolated cluster. And so when we do that, we still don't have any reduction in the quality of the model, but the elapsed time is greatly reduced from this 22.6 hours to 8.75 hours because we're able to run in parallel. The idle cost is greatly reduced because now the head is only running when you're idle. And the workload cost is greatly reduced because of 2 reasons. One is auto-scaling, so that's the bottom reason, which we expected. We knew that we didn't need all 3 workers during the full run. The second one is that Luna was able to find cheaper resources, which I wasn't willing to do as a person trying different things, but Luna was able to run the workers on cheaper instances than the head. The head needed the bigger instance anyway. Remaining opportunity, really close now. Remaining opportunity is to run on the CPU head itself. That would be much cheaper than a GPU instance, and it would allow you possibly to leave the cluster up all the time. Like I would feel kind of guilty to leave the cluster up all the time, even with just the GPU head. But once you're running a CPU head, you can see how much cheaper it is. So again, no compromise on the quality of the model results, but lapse time was a little slower than 8.75, which we got with the GPU head because the CPU head is a little slower at running the evaluation of the models, but still much faster than 22.6 hours. But the idle cost here, the CPU that Luna found for me only cost 0.452 an hour, which I might be willing to just leave up all the time for the convenience when it's so much cheaper than a GPU head. The baseline difference in the running cost was pretty much similar to the other one, and this is the breakdown, so you can see it's similar. So in general, we learned that, I learned and shared with you that using Luna technology in a Kubernetes cluster in the cloud, working together with the Ray autoscaler, can save a lot of money, can save a lot of operational hassle, and is really worth doing. So anyway, that's it. Our future work will continue to enhance Luna to handle efficient scaling across diverse Kubernetes workloads and the public cloud vendors, and we'll continue to enhance Ludwig AutoML to take advantage of the power of Luna to allow public clouds to scale well for deep learning jobs. So anyway, thanks for your patience, and appreciate it. And any questions? I don't know if we have time for any questions, but. Thank you. Thank you. Okay. Yeah. Exactly. I think so, yes. Yes, I do.